first is the thing that comes out from running the code URL and passing route : first view in, so that's what it looks up. And we can make a link. This is now an href, and the actual path is sitting there in the href. So now we're going to see how we do this when we're going from one application to another. So an application we're going to look at in just a bit is this thing called the generic views. It's an application called gview. And we want to make a link to that application, and we know that there are two views. There's a list view and a detail view. And all we have to do is go take a look at the urls.py, and we know that it's an application gview, and this view has a name and that view has a name. The view that is all the cats is got a name of cats, and the view for a single cat is cat. But the cat one takes a parameter. It's an integer number, which is cat number 42 or whatever. And so we're sitting here in the route application, main.html, and we can now go create a URL that actually is pointing to another application and a view within that other application. So this is a URL for gview cats, and that'll just look it up. So now we don't even have to know what the URL patterns are inside of gview/cats. Now, we can look at gview_cat, which is this URL, but you'll notice that this has a parameter, and so we actually have to add a second parameter, which is that 42 number. And so this will generate the URL straight to the detail page for a single cat. Now, there's a lot of nice stuff about this. So for example, if you omit this, it's going to look this gview_cat up and find it and say, you know what, I'm supposed to have an integer, and it'll blow up on you, right, if you get that wrong. Or if you put a 42 on this one, on the gview_cats, you're not supposed to have a number on that. But gview_cat, you are supposed to have a number. So this is one of the nice things about this reverse URL lookup, in that we can, there's some error checking that goes on, because if it could just blow up silently, and in many ways when code blows up silently, it's worse than blowing up in a spectacular fashion, because if it blows up in a spectacular fashion, you can fix it. So this is what it looks like. So this gview_cats URL and gview_cat42, this one that actually is the detail page that demands a parameter, it constructs that just fine. Okay? So that's going from the route application to the gview application. Now, you can also, this is kind of subtle, and we will need it when we start doing social login using GitHub. So I'll just mention it because we're deep in it right now. And so basically this is actually the overall DJ Free samples urls.py, and that's the one that's pulling all the URLs together kind of in the same folder as settings.py. And so you're pulling in a bunch of URLs, and these live in an application of their own name, but we can actually give them a name of our own to reference them. So you can actually name them, you can reference them with the name they were already given by the application that we're talking to, or we can say, you know what, I'm going to call these social : or nsroute : So if we take this route application and include all those URLs, and we're going to use a namespace of nsroute, you still can say route : or you can also say nsroute. And so you can see that in this example, right? We can go to the second view of route, or we can go to the second view of ns. And so there's route. Route is one way in, but nsroute is our own way in case we somewhere have an application named route or something like that. And so this allows for a second way to access these URLs using a namespace. And it's not in the urls.py in each application. It is in the urls.py for the Django project. So I just finished showing you all that in the templates, but we can also do this in Python, and we'll find that sometimes in like models.py or views.py, or even sometimes in admin.py, we'll need to sort of be able to find a view in the same or another application and automatically construct it. Sometimes in forms.py, we're going to do it as well. And so this, you tend to call this reverse or reverse lazy to look these things up. And the URL feature inside of the template is pretty much just calling this reverse lazy automatically, because the parameters are kind of the same. So I just want to show you how to do some of those things that I just showed you in templates, how you can do them in Python as well. So here's the one in templates. We just have this little plugin to a template called the URL plugin. It takes one parameter and looks up in the urls.py of the first application, the URL named first view. Maybe there's parameters, in this case there's not, and then it generates a path to that, /route/first, right? And so that's how you do it. It's really under the covers calling this reverse lazy. And so these reverse and reverse lazy are from the Django.urls library. And so in this view, there's nothing tricky about this view. It's just a class-based view. We have a get method. We pass in all the request stuff. But basically, we can call reverse lazy and pass it the exact same string, which is go into the GView application, work your way down until you find the cats, or go into the GView application, go in and find the one for dogs, or in this case, this is the dog detail, and it requires a number, and so this GView dog, go find that one, and then the second parameter is 42, so make me one for that. And in Python, U2, and U3 are all just strings, which I'm passing in through some context under the variables x1, x2, and x3. They're really lousy choices of variable names, but I do that sometimes to point out that they're arbitrary and capricious and all they have to do is match. And so then like the x1 matches in this substitution, now we're just doing string substitutions, which is different than calling the URL, but it's still just a bunch of strings. You called reverse lazy in your Python code, and now you're just pulling that string into with double curly braces. And so this is how it ultimately works. We can, we get these, we're just showing how this output turns out, where we go reverse lazy for GView cats, GView dogs, or GView dog with an argument of 42. We pass it in, we replace it, and so this is how it prints out, GView cats /GView dog /GView dog 42. And so that's how that reversing works in Python. And you'll see that certain situations, whether you're like in a model, sometimes you're in a model, it's very common in a model to want to put something about the reverse in it. And the reverse lazy says delay until later to look it up. So up next, we're going to put this all together and ultimately start writing using the generic views, because we're going to look at list pages and detail pages, and in time we're going to look about delete pages and update pages. And Django has these wonderful features that make it work really simply with very little code. But we want to talk about it because sometimes the less code you write, the harder it is to understand. We're on to our last mini lecture about views, and it's a big one. It's about generic views. It's a really big lecture so that we end up with little tiny views with one line of code. So I've been building up views, and we've talked about inheritance with the templates, and now we're going to talk about inheritance and views. And we've been inheriting all along with views. So here we are in the views.py. This whole thing, these particular kinds of views, we define them in views.py, but they're very informed by the content of model.py, which means that views are constructed automatically just looking at the data in the models.py. So it's again sort of the logic of don't repeat yourself. If you have a thing in models.py, you've defined exactly what the fields are, and things like, what the help text is for this field and what the description for the field is, that has nothing to do with the database, but it can inform the views. And so it's just a way for, you'll see how it all fits together nicely, but sometimes when we use these super awesome techniques, we end up with a little tiny bit of code, and it's really important to deeply understand that tiny bit of code, because you can sort of just fade away and not realize what's going on, because this code is so cleverly reusing a ton of other code and pulling stuff in from other places. So if you go all the way back to, we talked about SQL, the four basic operations are put data in a database, get data out of a database, delete that data, or update that data. CRUD, create, read, update, and delete. And we're going to build a bunch of things, whether they're add things or auto things, where we got to insert an auto, update an auto, delete an auto, list all the autos, insert a cat, delete a cat, list all the cats, update a cat, right? And so we have a bunch of user interfaces that we're going to build. over and over and over again. And as you build your own projects, you'll probably have 4 or 5 tables and then little CRUD user interfaces for each of the tables. And sometimes you make them a little different and there's pretty stuff on them and they're customized. But surprisingly often, these things just look the same and we end up repeating ourselves, which is something we don't want to do as software developers. So here is a simple CRUD application. It's the cur, create and read. Or no, actually, it's this one here is only read and detail. So we have a list of cats, and then you click on the cat list, and then you see the data for a particular cat, and then a link back to the list. So this is like a detail page. But we're going to do a lot more than that. But this, I just want to show you how these generic views work by keeping things very, very simple. So we're going to talk about a generic view in the list and the detail, which are 2 of several generic views. So this is our GView application, and here's the urls.py. In this GView, it has a list of cats, an individual cat, a list of dogs, an individual dog. And so you see this sort of repetition. And I'm putting so many of these in here because I'm going to show you sort of different approaches to implement them using less and more detail and less and more inheritance. So they're all kind of the same. I give them a name. You know, some have integer primary keys, and away you go. And so here is the cat list. I'm going to start with a template. So we're going to expect in the cat list template that there is a context variable called cat_list. And that is a list of cat objects. And then we are going to iterate through the cat list, however many cats there are, with inside of a list and generate an li tag, and then create a link URL, and then pull out the name of the cat. So the cat has a name, and the cat has a primary key, and so we are going to generate a link to the cat Sophie, and underneath that link is the link to /cat/12, whatever that number is. And if the cat list is empty, we're going to say there are no cats in the database. Now we've actually got a script that you use to preload all of this data. So there's instructions in the sample code as to how to preload that data. Take a look at the README for it. And so if we're in the detail page, we're going to pass a cat object in, and that has a name. And then we want a link to go back to the cat list. And so again, we're using something from the immediately previous lecture where we're using the URL macro, passing in the name of a view within an application. So this is the GView applications, the cat view, and then that makes for an href, that makes a valid link with the string go back to list to be the thing that does. So we're going to build all this stuff. And that's the basic idea, that template and the HTML, that's how we're going to do it. But we're going to look at how the views work. And again, this is a reminder of the dry principle, the don't repeat yourself principle. Again, sometimes this dry principle gets us in trouble because the idea is that some bit of logic is placed one place and reused as many places as possible, because don't repeat yourself would probably be as well described by calling reuse, 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 reuse. Do it once and then reuse it as many times as possible, so that if you have to fix it and you got a bug in it, you don't have to find the 49 places that you put all this code. And because we do the same thing over and over and over again, cats, dogs, horses, we do it over and over and over again, cars. The idea that you have a list view, a detail view, an edit view, etc., it's a common thing, and really, if you're going to do this stuff, why not make it look consistent and function consistently? If you have one developer build the cat's editing interface and another person develop the dog's editing interface, and they like go off the same, go off in their own way, and they got some groovy design, but it's different, who cares, right? It's inconsistent. So consistent, you still want a beautiful design, but you want the cat's data and the dog's data to make sense with that consistent design. So both of them can have a nice design. So we got templates. The templates expect variables, like the list expects a thing called cat_list or dog_list or whatever, and then the cat detail just has a cat variable in it, and then we call it. So if we just forgot about all the stuff that we're about to learn and we just wrote a view, it would look like this first one, this cat list view here. And so we would inherit from view. We're going to go to the database. We've imported the cat model, cat.objects. This is the way to query all the cat objects and get a list of cat objects and put it in the variable stuff. That's what cat.objects.all does. Now we've done this before like in the shell, but now we're doing it in actual Python code in the views. Like I said, views are where all the stuff happens. So that says make a database call, load all the cat records, turn them into objects, and give me a list of those objects. And then I'm going to pass in the context into the template, the gview/catlist.html, I'm going to pass an entire list. And if you go back and look, there was a little loop in the template that printed out, you know, Sophie, Frankie, and made links underneath them into the detail page. Okay? So this is how we would do it if we were going to not repeat ourselves. Okay? Now, this next way of doing it for the dogs, we're going to do it another way. And so what we're going to do is, it looks like it's more work, but it's more reusable. So the stuff that we're doing here. So what we're doing is now we have a dog list view, which is just a class, and we're going to create an attribute variable in this object called model. And we're just going to say that this model for this particular one is dog. So the idea now is in this get method, we take this code right here, and everywhere we said cat, make that be generic and have it be driven by this one variable. Okay? Now the tricky part that makes this a little tricky is sometimes we're just using the model, and then other times we are going to actually turn it into a text string. So if we take a look at this, we have this variable model, and in the get request, self.model is the way refer to the particular instance that we're in, that model variable. And this little meta verbose underscore name title to lowercase. You can figure that out by yourself by going to Stack Overflow eventually. That's how I figured it out. I wanted to get a lowercase version of the model name. So the model's name is a string DOG, which is not the same as the dog model. Okay? And so that just is a way, model name is going to be lowercase dog. But if model is cat, then model name will be lowercase cat in this bit. So I'm trying to make reusable code. So yes, the reusable code looks a little more complex because it's generic. But you'll notice that I'm creating a variable called model name underscore list because I'm just concatenating it together. So it's model name and is going to be dog underscore list. So that's what's going to happen. I am going to talk to the model and retrieve all the objects. That's okay. I don't have to change it to a string. Self.model is dog.objects.all. So then I'm going to get a list of all the objects and stuff, and I'll put that in the context. And then I'm going to go get myself a template out of the gview folder with the model name underscore list, so that what used to be cat list in here is now dog underscore list. I'm concatenating it together, and I passed the context in. And so then when that happens, then you get a dog list and some list of dogs, and away you go. So what I did is I generalized this code and put it in here, and then I passed in a sense, to the object that was made from the dog list view class, the actual model that I wanted it to operate on. Okay? So I do this to give you a sense of how this works. You can do the exact same thing for horses by doing this. And that is, you import the generic, Django views generic, right here, and you say, I'm going to make a class called horse list views. I'm going to extend not just view, but generic list view. So this is a generic class. You can go look at the Django documentation for this. It's a generic class that does a list view in general. And the rule for the class is you have to add one line here to say which model it functions on. And that's it. And that's because the get code is already in this model. We're extending that model. We're inheriting all this code, not from dog list view, but instead from generic list view. So we took something that was 5 lines, a little more generalized, it's like 8 lines, and now it's 1 line. And so that's how the extension works. But you have to trust, and you have to go read the documentation for list view to know how it is that you inform it as to what model you're supposed to use. So I want to show you a little bit of how this is happening by making one of these list views that's mine. It's not as cool as the real Django list view, just to give you a sense of what's going on behind the scenes in the Django list view. So if you say, so I'm going to make a new class, DJ4E list view, and then I'm going to extend view, and then I'm going to have a get method, and it's going to be all this code. It's looking for a variable called model, and you'll notice that it's not defining model up here because it's intended that this is a class that's going to be reused. So I'm going to say, oh, well, whatever the model is that's been set up here by the class that's being created while we're extending it, go grab that, convert it to a text, get the title of it, and then convert it to lowercase, make that model name. Whatever the model is, retrieve all of its objects and put it into stuff, and then put model name underscore list, you know, in this case car underscore list, and then pass that list into the template, and then render, you know, gview car underscore list context. Okay, so this is not doing anything per se. DJ4E list view is creating a class that I'm going to extend later, and I'm going to extend that 2 lines later. I'm making a car list view that extends DJ4E list view, and the only thing I need to do to get all of this code in here is extend it, and then I do need to add model equals car. So you'll notice that car list view has the exact same syntax as horse list view, right? Horse list view, you basically tell it, the generic list view, tell what model to work on, and then generic list view does it all. And if you look at car list view, it says use this generic list view that I just invented to show you the source code of what it is. That's the source code behind the scenes. Like I said, it's way more complex and sophisticated than what I did. This is the crudest, simplest version of an extendable generic list view. But when it's all said and done, you don't write any of those versions. You literally make a list view and tell it what model it is. You make a cat view and tell it what model it is. And you just reuse the list view over and over and over again. So the fact that I give you 4 different ways to do this, yeah, I think 4 different ways, maybe 5, 4 or 5 different ways to doing this. The real way to do it is one way, but when you look at code like that, you're like, horse list view is an extending generic list view and the model is horse. I'm trusting a lot. And the answer is, yeah, you get used to it. And now the code you have to write is only 2 lines of code. And you have to write the template still because it's going to call your templates, but it knows the name of the template by looking at that horse, right? It knows, oh, horse, oh yeah, horse underscore detail, right? Or horse underscore list. And so this is the actual detail page that shows you the horse and goes back to the list, etc., etc., etc. And so using these generic views, you can make things really short and really succinct and really simple. So generic views are excellent. They allow us to produce lots of similar pages without repeating ourselves. They keep your code consistent. The repeating yourself, doing the same thing over and over, even if it seems quick to cut, paste, change, cut, paste, change, cut, paste, change. If you really want to build reliable code and code that's thousands and thousands of lines with hundreds of features, you don't want to be able to you don't want to be pasting the same thing over and over. And so less lines of code means fewer mistakes. So this is kind of the end of our talk about views. It's really where we're going to start doing most of the work. The URLs, the models, they sort of don't get the kind of activity. Although we are going to talk upcoming about forms, which touch on views and they touch on models and they touch on templates. So forms are one of the things that lets us take our user experience and really up it. So we'll see you soon. Hello and welcome to our lecture on forms. There's actually quite a few lectures here because we're going to talk about how forms work in HTML and HTTP, and then we're going to talk about how they work in Django. So forms are the way that we put HTML in browsers that have fill-in-the-blank areas. And so the idea is that you draw some fields and some places for the user to type, and then you have some way of sending the data up to the server. And so we'll take a look at a number of different ways to gather this stuff up and send it to a server. There are two basic ways to talk to the server with form data. Everything we've been doing when you do an anchor tag is a GET request, which means you're going to get a document and show it. And you can put parameters on the end of those, like the question mark guess equals 42. You can put that on the end of a URL. But then what we're going to really introduce and talk more about is the notion of posting data. So in forms you can actually do getting or posting. And so let's take a look at some code here. So this is a little bit of utility code that I'm going to use over and over and over again because the get data and the post data and even the cookie data and stuff come in as dictionaries. They look like dictionaries, key value pairs. And so I just wanted a way to dump the data. I want a little label, probably should call that guy label, and then a dictionary. And so I'm just going to retrieve, go through all the items and call HTML escape so that we just don't end up with HTML cross-site scripting injection. Just print the keys and values out and put some paragraph tags and stuff like that. So it's just a way to dump this out so I can show it to you and not put this code on every one of my slides. So just remember that that's what dump data does. And here is a little form that prints out a form and then retrieves the form. So you'll note the dump data. If there is no data in request.get, it doesn't print anything out. But this ends up producing a form, right? And there's a form tag, there's an input tag. Input is the painting. Just put some text out, and then this label, this box here, is the input type equals text, name equals guess, size equals 40, and then we put a submit button out. And we can type some stuff in, and we can hit the submit button, type 42 in, and hit submit button. And you will notice that once this submit button is hit, it adds automatically onto the end of the URL that it came from, question mark guess equals 42, and then it sends that back and does another GET request, but this time it does a GET request with question mark equals 42. In comes this guess equals 42 is put onto the request.get, and then we dump it out so we get to see the key value pair of guess equals 42. And again, Django's taking care of all that parsing and everything before we get to it. Now, this is pretty much the exact same thing. Later we're going to talk about this CSRF exempt. This is to keep it as simple as possible for now. And all we have to do is tell that we would like to communicate this same form of data, one input field and a submit button. We're going to communicate this from the browser to the server using the post method. And so this is a communication to the browser when the server says, I would like to send this data using the technique of post, not the technique of get. And so, it prints out, we put in the number, we submit it, and so the first thing that you'll notice is there's no key value pairs, and that's because the post actually transports the data to the server in a different way. And it appears in a different key value pair. We can tell whether it's a post or a get, and if it's a get, we get our get parameters in request.get, and if it's a post, we get our post parameters in request.post. And so we still get the same guess keyword equals the number 42, okay? And so that's simply the two ways of transporting it. And this is talking about those two ways, right? The browser has a form, blah, 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 input type equals guess. And the name field, name equals guess, is the field that is going to tell what the key value pair is. So if you're going to put a post, you're going to hit the submit button on a get form, it does a get to wherever it came from, right? And then appends the key value pair to the end. And again, that goes into Django, which parses it and puts it in request.get, etc., etc., etc. And if all you do is you tell it with a method equals post, then it chooses a different way. So the post is going to the same URL, but there are no parameters here. And so there's a series of headers like, what is my preferred language, etc., etc., what I'm using for my browser, the content type is this application URL form encoded, and that's talking about this. Now remember, this is going into the server, so the content type coming out tells if it's an HTML page or a JPEG, but the content type going in tells the server how to parse this. So it leaves a blank line, it's very symmetric with how the server sends us pages back, and then guess equals 42. Now, there's some complexity here, and there's some complexity in that post data, and there is some complexity in the get parameters where if you're sending special characters, there's ways they have to be encoded, but we're going to ignore that for now. Just understand that the reason you don't see the parameters on the post request is the data has been transported as part of the HTTP connection, and it's later on in the connection after all the headers have been sent. So you might say it doesn't matter. Well, it does matter. So there's a couple of simple rules. The post needs to be used when data is going to be created or modified, and we'll see situations where we force this, where you don't want to delete something on a GET request. If you're reading or searching, GET is great. It should never be used to insert, modify, or delete data, anything that's going to change the state of the system. And part of the problem is that web spiders will find GET requests. So you might, if you build a bad application and like a catalog of bearings, for example, and you have a delete that happens to be a GET request, and a web spider grabs your page and hits all those URLs, you might find that the web spider just wiped out your database. So web spiders do not follow posts because they assume that by following posts they might be changing your data, but by following GETs, they're just reading your data, and that's all a web spider really wants to do. Unless, of course, it's doing some kind of automation. So GET URLs are supposed to be idempotent. So the idea is if you say blah, 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 guess equals 42, it's supposed to kind of give you back the same page. Now, that's like saying, blah, 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 current calendar. Well, what is the current calendar? It might be, it's not identical, but it is sort of semantically the same thing. So you're supposed to be able to go bookmark a GET. You can bookmark a GET URL, but not, like you might say, where's my inbox? Here's a URL to my inbox in some kind of a system to read my data. And so you can bookmark that and go back to your inbox. It should be a GET request. You shouldn't be bookmarking posters. The other thing is that depending on your browser, your web server software, etc., you may have an upper limit on the GET. Let's just think 2,000 characters. Doesn't mean you should worry about it too much, but just large things, especially when we start uploading files like pictures, then all of a sudden the GET is impossible and you have to use post. And it also has the advantage that post doesn't mess up keeps your URLs looking prettier. So next we're just going to do a quick review of the kinds of things that you can do in forms and HTML and different kind of input tags we can show in our HTML. So now we're going to do a real simple run through of the kinds of things that you can do in HTML and forms. This is only the beginning, and there's so many great online resources for how to do forms in HTML. So I've already showed you the basic text field. We'll talk about the password field, radio button, checkbox, select, and drop down. And I just got kind of this one HTML page that you can view the source of and borrow. I kind of write this stuff up for me for a quick reference. So we've already talked about the text field, right? So input type equals text, and then the name is the value. The ID, don't get too stuck on the ID. The ID has to do with how you associate the label tag with the field, and so that knows that somehow account and this text box are connected. So the ID is more of a browser thing, and the name equals is the thing it's going to be sent to the browser. So the browser is always going to get key value pairs. And so, when we type Beth and we hit submit, then we're going to get the incoming post data is going to have the value account equals Beth. Now, if you look at password, that's a type. Password, for all intents and purposes, is a text type. And it shows it so people can't shoulder surf and see what it is. Of course, they can watch you type your password, but it shows asterisks in the box while you're typing. But then it's important to realize that once the data is submitted, the data is submitted in plain text. And so here's another one, another nickname. So Nick equals NICK. So that's basically the variance of the input types of text. Hidden, type equals hidden is another one where you just don't see it in the user interface. We're going to use one of those input type equals hidden in a bit. A radio button is designed for situations where you can only pick one of two things. So when you hit AM, the PM goes off. When you hit PM, the AM goes off. And you can actually have a whole bunch of them, and you can click them. Now they're drawn together because they're type equals radio, and then the name is identical. And interestingly, you can scatter these literally all over the page. It doesn't lead to very good user interface, but away you go. And so what happens is again, no matter how many of these you put with a name equals when, no matter where you put them on the page, if you click one, all the others are going to turn off. And so the one that's clicked, they all have different values. And so what will happen is whatever one is clicked at the moment that you actually send it, that will be the key value pair, where when equals PM, because only one can be selected, and it's up to you to make these things unique. Or maybe you don't want them unique. You do whatever you want. And so in this case, the PM one is selected, so we see when equals PM in the incoming post data. So that's a radio button. So this is a checkbox. This is probably more useful in many ways. Checkboxes, you can have as many that you want, and each of them are individual and distinct. So if you take a look, for example, you see that you have different names: class 1, class 2, and class 3, right? So that each checkbox has its own name, but the checkboxes are actually just little checkboxes. The text here is just text. The text is not really a critical part of it. The value is what will get sent if that checkbox is checked. And so in this example, we've checked Pi free and SI 539, and you'll notice that two of them have values and one of them doesn't. Now the key is often you're just checking to see if the data is there. In this case, class 3 is not in the post data, and class 1 is on. That's the default. If you don't say value equals, it's like value equals on, or whatever the value is that you put in that checkbox. And so you get to decide these. You might easily think that you don't need any values whatsoever because you're really looking for the name of the field, and you want the name of the field to be distinct. And so again, you can check as many of the checkboxes as you want. You can uncheck them, you can check none of them, and you can check all of them. So those are checkboxes. So to describe a drop-down is a multiple choice option basically for a single value that's going to be sent back to you. And so we have a select, which is the whole thing, and that gives the name, the keyword that it's going to be sent back to. And then we have a series of options, and you'll notice there's no value on the select, but each option has its own value, right? So I happen to be going 0, 1, 2, and these are strings, not numbers. They often are just numbers to make our lives simple. And then you have some text, etc., etc., etc. And so you pick one. In this case, I leave it default, and I hit the submit. So soda is going to be equal to 0. So this happened to be the one that's selected when we hit submit. Okay? So that's what a select looks like. You can also make a select that has some defaulted one, and so you just put selected on one of them. So that means it's the drop down. They're all there, right? They're all there. If you click on this thing, you'll see, if you click on which snack, you're going to see all the different snacks. Peanuts is pre-selected. And if I don't change it and hit submit, then we're going to see snack equals the value, which is peanuts. So that's an example that you don't have to make numbers, although it's really common to be using numbers. So that's a drop down with a default other than the first item. The default is it's the first item unless you do it otherwise. When you're typing in comments or a blog post, a big long blob of text, you use a text area tag. The text area tag is a little bit different in that it doesn't have a value equals. It does have a name equals. It has rows and columns to tell how tall it is and how wide it is. There are clever styling libraries that make these a little prettier. But basically what it is, it's a series of text, including paragraphs, including new lines, etc. And you're just allowed to type with new lines and edit and cursor around in here and build all kind of stuff. And then you send it in, and you can put default text in here. You can edit the text, you can change it, and it comes in as a key value pair with new lines and everything and any weird spacing that you might put in. But it's basically a block of text, like a comment or like a comment or a blog post or something like that. So the last thing on this page here is the submit button. And so you can make a type equals submit, and you can give it a name, and again that's a key value pair and a value. Now the submit is a little bit weird in that the value actually appears on the submit. What we tend to do is this submit, and if you're in a multi-language environment, you're going to want that to be whatever language of the user. So usually what we do is I carefully name the variables, or the name of the form, and then I check for this to exist. And if I have a bunch of buttons, I name them differently and don't really actually look at this text, because that text might want to be translated at some point in time. So that's an input type. Input type equals button. This is a little pattern where I'm going to do like an escape or a back or something like that. And then sometimes it's easier just to do a little JavaScript. And what this little JavaScript chunk is, location.href equals quote www.djfree.com return false. What this says is it actually sort of, when you press this escape button, it goes up in the browser and in effect pastes this little URL into the URL bar and then hits enter, and return false keeps the form from being submitted. And so this is a way that I often will put a simple cancel or escape or something else in a form. Just if I know the URL I want to go back to or go to, then you can put it in here and on-click location.href. So those are the input types that have been around for probably 20 years. Yeah, at least 20, 25 years. HTML5 is a more recent phenomenon, although by now it's pretty well supported in most browsers. Defined a whole new set of input types. And what's nice about this is we were slowly but surely building complex libraries to solve all these problems. But now we can use these input types, and now each browser can support them to their own way. And they all fall back to type equals text. And so if you have a really old browser, these don't cause trouble. So here's just some samples of some things. So type equals color is a color picker, and that's going to pop up a color picker, let you cruise around. That color picker is defined by the browser and usually the operating system, and so you'll pick a color, and then that color is going to go in hex format, and that's the red, the green, and the blue, and so that's what colors look like. You can have type equals date, and so here's a date, and they pop in here. You're going to pop up a date picker for the birthday. You'll pop up a date picker, and you'll be able to kind of move around and pick a date, and then that'll put that date in as a string. They're all going to turn into strings when they're being sent in. A couple of the other ones, like email, name equals email, that basically does validation that says it's got to have an @ sign. There's some rules about what is and isn't a valid email, and so this will refuse to submit this form unless there's a valid email in there. The same is true for number. If you put something that's like 25 and it's not between 1 and 5 with min and max here, it's going to refuse to submit the form. The same is true for a type equals URL. It's really a validation on the form to say, look, you can't put something in here that's not a valid URL. And just to prove that it doesn't matter, if you make any type, which flying doesn't exist, you can type something in and it just functions as a text field. And so in a way, all these fall back to text fields. Now the key thing is when you hit the submit button, normally that gathers up the form and sends it to the server. But when you use this HTML5 validation like date, number, email, URL, it actually will, before you hit the submit button, before it actually sends it, it's going to do a quick validation on these things. And it will actually stop and say, you know what, you didn't get that one right. And it just refuses to submit. So you can't override that in your application. What happens is the data doesn't get submitted at all so the browser blocks the submission of the data. Now, if it's not an HTML5 browser, it's going to get submitted with no validation whatsoever. So we still have to kind of check this data for sanity, which we'll talk about soon about how to do that in the server. But this is quite nice because it gives your user some immediate feedback, kind of customized to the browser, so the browser takes some responsibility for helping get the user to type the right stuff in. And so that is a romp through HTML forms. You will learn so much more. I just wanted to kind of cover some of them in case you hadn't seen it in a while. Now that we've talked about forms a bit, I want to talk a little bit about security in forms. I want to talk about a security issue called cross-site request forgery, or CSRF. So the idea of a CSRF attack is that a rogue site it has to do with cookies and how cookies get sent to sites. So let's say you're logged into my site, and a rogue site generates a page that's going to post. And on every form you can post to a site other than the one it came from. And so if I can get data that I want to send to the legitimate server, the rogue site can set up a post, and then if I can convince you to hit the button, then it will grab the cookie and send it to the legitimate server that you're already logged into and perhaps do something dangerous. And so the rogue server doesn't need to know the cookie. The rogue server just needs to convince you to click on a rogue form to send to the request server. So the defense for CSRF is don't be confused with session. It is going to use session. We're going to grab another large random number, and we're going to call it the CSRF token, and we're going to stick that in the session. And then what we do is every time we send a form out that's coming from our server, we add a little input hidden tag that has this CSRF token. And then when the post comes in, we check the CSRF token that's coming in the post data, and then we check it against the one that's in the session, and then rejects it if it doesn't match. So here's a picture of how this works, right? So we'll have a legitimate server, right? We're going to produce a page by the legitimate server, and it's going to post back to this same server. The action is the URL to send the post data to, and we got some key value pairs and a submit button, right? So you hit the submit button, and it's going to come back to the server. Now, one of the things that the browser is supposed to do is pull the cookies for that server and send it. So it sends it both a post and the data, but it also sends the session ID cookie. And then what happens is that the Django gets its hands on it. It looks up the session ID, pulls it in, and notices that it's C7 and I've been logged as an instructor. And then I can actually change this grade and set the grade, and it works. Okay. Now, here is what happens when you get to a CSRF attack. So somehow a page gets sent to the server, right? Sent from a rogue server, and it just has this form. Method equals post, action equals DJ. It's not the action, it's going to a different place. And it puts sort of a new grade and then a submit. So what happens is this submit comes in, and the browser dutifully appends the cookie to it, and it sends it. Now, you had to be tricked into getting to this page and sometimes tricked into submitting the page. But once the post comes in, it has legit cookie in it. The cookie is used to look up the session and reassociate it, and we can check in the session that the user is indeed logged in, and we'll let the thing set the grade to 1.0. So this would be a way, if you could convince a logged in instructor to run a post form that you created, you could basically change your grades. So that's how it works. That's how a CSRF attack. You have to be tricked twice first, but there's ways in JavaScript to make it so it's hardly noticeable that you get tricked. So if you do this with CSRF, the legit server basically adds another value, not the session ID, but another value in the session, which is a large randomly chosen number. And then when a page comes out, it's a legit page, and it uses a type hidden variable and puts the CSRF value in. Now you hit the submit button, and the CSRF is coming in as post data. Your regular data, the grade data is coming in, and the browser dutifully appends the session. And so then using the session cookie, it reassociates the session, says, yep, you're C7, you're the instructor, and the CSRF works, CSRF matches, so let's go ahead and let you set the grade. So we let them in. With the attack blocked, because the rogue server can generate a page, but it doesn't know what the CSRF is. So it could, who knows what the CSRF is, so it generates it. Maybe it can put a CSRF, but it doesn't know it. So then the post happens, and all the data gets gathered up, and so it sends the CSRF, but it's not the right CSRF. The session ID is sent in, and so the session is pulled in. We know it's user C7, we know it's instructor, but we're going to check to see if the CSRF matches, and then it blows up. And so then you just refuse the post, probably log the user out, and then log some kind of a security error. So the idea is by having this little CSRF number in the session, we can then take care of that. So like most things, Django comes out of the box with CSRF protection built in. Just like the session, we've got CSRF middleware just dropped in. And actually it works automatically. You don't even have to ask for it to work. Once you have a session, it starts putting out CSRF things. So up next, we'll talk about, now that we know the concept of CSRF, we'll talk about how we're going to use CSRF inside of forms to implement sort of CSRF protection. So now that we've introduced CSRF conceptually, let's talk about how we actually implement it running in Django. So if you remember, I didn't really point this out too much when we went through it. This was my first form where I showed you how data could be transported to the server using a post request. If you look at the top, I have this little annotation at CSRF_exempt, and there's a little import above it in the views file. And what I was basically telling Django is don't blow this up because I'm not handling CSRF properly. So what we're going to do is we're going to do the exact same view, except we're just not going to have that little thing. And so we'll call this one fail form. And we're going to throw out a form. We're going to press submit. Everything looks fine. The only difference is I did not turn off CSRF processing. So on a post request, CSRF processing is on by default, which means that we have to do something explicitly when we're making post forms. But I didn't do it yet, so this is what happens if you don't do it. So you get a form and you press type some stuff in and you hit submit query, and boom, you get this forbidden message. That's a 403. So among all the HTTP responses, we've got 200, which is okay, we've got 302, which is moved, and we got 404, which is not found. 403 is you're not getting this page, but not because I don't have it, but because you're not authorized to do it. So this is it aborting and stopping the post. So it comes in, it looked up the session, and everything looked good except the CSRF did not match. Now, we are a legit server, so what we've got to do is we've got to actually add the CSRF to the post on the way out. Okay, so this is the exact same post, and I'm doing this kind of at a low level, and we'll show you a much easier way to do it in a minute. So we have an input hidden. I just happen to know that CSRF middleware token is the proper name for it, and I'm just going to have a placeholder which is __ token. And so then what I'm going to do is I'm going to talk to that middleware CSRF get token. Now that token is probably just a number sitting in the session, but I don't need to know that. I just say, hey, give me the token for the current request. The request is, of course, all that data that's coming in. It's got the sessions, got everything else in it. So, hey, give me that token. This is a big, long string, which is really just a big, long random number, a big, long random string. And then what I'm going to do is take whatever that big, long random number is, and I'm going to replace this little bit with a stir, a simple replace, and then I'm going to send that out. So this time, when we go to that page, you'll see that now we have an input type equals hidden, name equals CSRF middleware token, and then the big long middleware token, whatever that is. And then now when we submit it, it bundles up both the guess and the middleware token, and it actually bundles up the submit as well if it's got a name, and sends that in as post data. So now when it dumps out, you see, oh, well, you got guess equals 42 and CSRF middleware. Now, by the time it's got to this point, we're not really doing the checking here. The checking was done before the view started. And so if we go back to the view here, the checking is done before it gets to here. When you're dispatching from a urls.py to this, and it says, you didn't tell me not to do CSRF, and it's not done properly, so I'm going to blow you up. So if it's going to work, it's already worked. The fact that we've come in here and we're dumping this stuff out of the post, that's just sort of like we see it, but it would have blown up before it would have even got to our code at that point. But we do get it and see it as post data. We don't need to, because if by the very fact that our view is running means that the CSRF processing has been successful. Okay? And again, the rogue system has to somehow get its hands on this, the actual number of the CSRF, and that changes every time you log in, and literally it could change every hour or so or whatever. And so it's a hard number to guess, and it's a hard number to get your hands on. Now, that manual thing is not the easiest way to put this in. There's an easy way in CSRF. You simply say So here's our form, here's our slash form. I do all the stuff I want to do that I want to do, and then I use the code. This is called a template tag. When you have CSRF enabled in your Python, you have a template tag of CSRF underscore token. And that emits the input, the type equals hidden, the right name, and all that stuff. So you, as the developer using templates, you don't have to know anything about that, okay? And so that's how we do CSRF. And the only other thing we got is a guessing game, and then we're going to pass a message into that, and we're going to do that in a bit. We're going to use this for a whole bunch of little examples. So kind of remember this particular guess.html template. But the key right now that we're talking about is the fact that we've got this CSRF token in. Now, I'm going to write a bunch of guessing games, and these guessing games I'm actually going to start checking the guesses. So I'm going to have a function in this view that's called checkGuess, and it's pretty simple. It returns a string or false. If the guess is an actual non-false thing, we check to see if it's too low, too high, or right on time. Or if it doesn't convert, if this int guess throws a trace back, well, then we'll say bad format equals guess, and then just because it probably came from the user, we're going to escape it and then send that back. So whatever it does, we're going to send back a nice little message going back. And so here is a simple guessing game that we're going to do. And so so we're using a view-based view, a class-based view this time. Of course, we extend the class view. And remember how it works is it's not just a function. We actually have two methods. One is a get request, and the get is called when we're receiving get request, and the post is called when we're receiving a post request. This alone is one of the nice reasons to do this. You don't actually have to say, if it's a get, do one thing, if it's a post, do another thing. We just have two methods, and Django properly routes the requests in. Okay, and so this is going to be a form post. So on a get, we just render with no messages. We render with no messages. And we have a CSRF token that goes out, so we just render it. Then we'll click the button so that this render right here will produce this page. Then we type in the guess of 42 and we hit submit query, and then that bundles it all up, including CSRF, and goes to the post. Now the CSRF, as long as we put it in that template, we don't care, because before that post method gets activated, CSRF has been processed, and we get a 403 if the CSRF isn't right. So if we go back up here, and you don't put this in, and you run this code, this CSRF token, you don't put it in, then when you hit it's never going to make it to the post. I mean, it blows up en route to the post if the CSRF doesn't happen. But we've got CSRF, and it's all automatic. We just throw that one line inside of our form, and that's all we've got to do. So we put 42 in, we hit submit query, passes CSRF, it comes in. So we grab the post data, the guess from the post data. We call my little check message, check guess. That's going to give me that little message, whether it's too low, too high, or some kind of other mistake. And then I'm going to pass in a context. The string message has that string. And if then we go, do I have it down here? No, I have it up here. So then the message comes out. So this, you'll notice I've surrounded this by an if, so that if message is false or not present, then it doesn't put anything out. But if it is, it actually puts the message out. And so out comes the guess. And so this is what it looks like when we do a get request, right? We see this. Then we're going to see all this, stuff. We're going to type our number in. We're going to hit submit query, and then it's going to fire up a post request. And so then it's going to come back into the post request. It's going to get the guess from the post data. It's going to check it, and then it's going to pass the message in. And so the message is going to come out here, and then we're going to return that page. And so you're going to see something like congratulations 42. So that was part of the post, and so we now have made a successful guessing game. So next we're going to talk about, just when we get something working, there's always something that we have to say, oh, but there's a little detail that we forgot about. So up next we'll talk about post and refresh, which is a little problem that we're just going to have to fix. So these forms are kind of complicated. There's a lot of little details. Once we get them, then we'll be able to knock out forms and just do form after form after form. So I call this little section post refresh oops. So remember this little page not so long ago where I'm like, look, it's great. We did CSRF and we checked it and it worked great and we put the CSRF token in and it's all good. Well, it turns out from the heights of success is the depths of failure. But it's not too bad, not too hard to fix it. So we just got to fix it. So the problem is if the browser sends a post request and it gets back a 200 in a page of HTML, which is exactly what we just did, and then you hit the refresh button on your browser, the browser is going to resend the post request. And if you go back, I said post requests are things that change. So for example, if you are transferring money from your account to someone else's and you hit the transfer button, it's a post and money gets transferred and then transfer successful. And then if you hit refresh, you're going to post it again. And so the refresh basically reruns the entire previous transaction. It doesn't just grab the page, it sends the post data again. So if you transferred $100 in one post and you hit refresh, you're going to transfer $100 again. So what happens is that because the browsers know that posts are potentially dangerous to the server, the user will get a pop-up, not from you, but from the browser to say, hey, this person who built this server application left you sitting on a post and you hit refresh and I'm going to about post it again. So are you sure you really want to do that? And the problem is the user doesn't even know what a post is, barely knows what's a refresh, and it looks like a mess. So the way to do this is you go to the page, you type in 42, you hit submit query and it'll say congratulations. And you look at it and then you press the refresh button, the reload button. And you press the reload button and it says, to display this page, Firefox must send information that will repeat an action such as a search order confirmation that was performed earlier or a money transfer. That is not a message from your application. That is literally because your application was a little sloppy and Firefox is like, I'm really not sure if we should do this, so I'm going to ask the user. But it doesn't exactly know what to ask the user. It doesn't know what you just did. And so it's a yucky message, and what we want to do as programmers is avoid this. We want all the message, all the user experience coming from us, not having the browsers take over some of these things. And so it's just bad practice in general to send a 200 post, to take a post request and then send a 200 with an HTML page back. Okay, and so it's just ugly. The browser asks, it's out of your control, it's ugly, it's bad usability. So we can do a little bit of work to make this never happen. And so that's what we want to do here. So the way we do this is through what we call post, redirect, refresh. So up next, we're going to show how we're going to fix all this using a post, redirect, get, refresh. These titles keep getting longer and longer. Hello and welcome to my lecture on cookies and sessions. So taking a look at sort of how all this stuff works out, we're again in our application. And so there's two distinct topics that we're going to cover, and it's really important to keep them clear. So there's cookies, which are a browser concept, and then there are sessions, which are a server concept. When we write Python code in like our views.py, we talk to the session. Cookies are essential to sessions. Cookies are used to look up which among the sessions that we're going to use. So what we're going to do is I'm going to first talk about really just the cookies, how cookies talk, how the servers talk to the cookies, and then separately we'll talk about sessions. So keep the two concepts the same. A lot of people tend to confuse the concept of sessions and cookies because one of the most common use of cookies is to establish and maintain sessions. So the first thing about the web in general is that you have a web server, and when you're just developing you think there's only one person, which is you talking to the web server. But in reality, when a web server is in production connected to the internet, there could be 1,000 connections to 1,000 different browsers. And it's essential that the server can figure out at any moment which browser it is talking to. We don't maintain a permanent connection to these browsers. That's one of the reasons that the internet scales as high as it does, right? But so we still have to have some way of distinguishing when a request comes in from this server versus when it comes in from that server. And so what we want to do is we want a way to basically put a little mark on each browser and say, oh, that's this browser. And so when you log in from this browser, I can know that it's you. So marking the browser is different from saying I have browser 41, 42, 43, 44, and there's each browser ends up with a mark. In the early days, the web was pretty much a read-only medium. We didn't do a lot of logging in. We didn't do a lot of uploading. There were password mechanisms, but they were very, very clunky. And so all the browsers were pretty much reading the same information, and as long as you're not logging in and modifying stuff, it just doesn't matter. So quickly, in the early days of the web, the idea of a cookie was created, and that was a way for the server to store a little bit of data on each of the browsers. And they're just little pieces of data written by the servers, read by the servers, sent by the browsers, and read by the servers. Now, it has nothing to do with logging in. It has to do with writing a little mark on every browser and then getting that browser mark back every time we ask it. So often when a server gets a first request from a web page that doesn't have its little mark on it, it makes up a number and sends that cookie back. So it sets the cookie that there may be many interactions between the time you're starting to talk to a server and when you log in. But often the cookie is set immediately. But the key is that once I set that cookie, it's like storage for my server on your browser, and each of the servers and that can be sort of temporary or permanent storage. So they're marked in the browser by the web addresses they came from. It's a security thing. You're not allowed to read cookies from a page. If your page comes from a particular server, it can only read the cookies associated with that server and vice versa. So they're like a little stovepiped. Cookies have an expiration date. There is two kinds of expiration dates. There's sort of by a certain time or a number of seconds, or there is stay logged in or keep this cookie until the browser is shut down. We call those session cookies, which is kind of weird because we often use them. We often use session cookies for sessions, but we still got to keep them session cookies. So here's a bit of sample code. So one of the things you can do is you can go into your browser console and you find something like storage, and you can see for the website of the current page, the current website that you're on, that website's cookies are stored here. And so I'm looking at the cookies here, and I see there's only one cookie, this CFDUID. This server is using a proxy to help speed itself up, and so that cookie's not really part of our application. And so what happens is there is no cookie, it's not set, and so we go in and click on this if you give a browser a cookie. And it's going to route to this particular view, and so in this we're going to do a print of request.cookies. So what happens is I mentioned that every time a web request comes in, all the cookies get sent in with that web request that are associated with that server. So we're going to print them out, and they come in just like request.get, request.post, and request.cookies is Django's way of handing us all that information. And so in this case, I'm not actually going to send the response back in the return value. I'm actually going to create the response. That's RESP HTTP response with a string. And then I'm going to set some cookies. So cookies are part of the response. They're actually part of the headers of the response. And I'm going to just set one cookie. They're my names. I set them. This application, cookie named Zap to 42, and then a cookie named Sakai Car with a value of 42, and I give it 1,000 seconds. So that's one is a session cookie, and the other is a cookie with a fixed expiration date. Now this 1,000 seconds, you can go much longer than 1,000 seconds. If you start looking at the cookies that you're talking to on the various things, these are year-long, multi-year cookies, etc., etc., etc. And so if you were to see the printout that is coming from that request.cookies, you would see that it's basically a dictionary of key value pairs. Now that's after the second response. So if we go and we click on the cookie and we start with no cookies whatsoever, we're going to send this code out, and it's going to send two cookies back. And so what you can see here is you can see, if you look closely, in the response headers, two set cookie responses. So the response headers are like the content type, etc., etc., etc. They're not the actual page. The actual page is C is for cookie, and it's good enough for me. But basically, when this response came back, the server said, hey, set this key value pair and this key value pair and have this second one expire, which is exactly what I did inside that code. And so now if we take a quick look and we take a look in our storage, what we're going to see is that we now have two values. Sakai car is 42, zap is also 42. Sakai car is going to expire a certain amount of time in the future, and zap is a session cookie because we gave it with no expiration, which means once I want to close all the tabs in my browser and close the browser, then the browser will throw this away. The Sakai car will be persisted to disk or some other place, so that if I close all my browsers and open browsers up and go back to this website, samplesdj4e.com, it'll start sending that cookie. So that's a permanent cookie with an expiration date on it. Now that's pretty short expiration. 1,000 seconds is like, what, 20 minutes, I think. And so that's going to go away. But a lot of these cookies last much longer. So that's after the set cookie comes back from the server. Then we can take a look and we can see as we make another request, we're going to see that the browser is going to look up the cookies, and we have this one here that's part of the hosting environment, but zap equals 42 Sakai car. So now in goes a GET request, and as part of the request headers, it's telling us all the cookie values for samples.dj4e.com. And then when I look in my code and I say request.cookies contains the parsed versions of zap 42 and Sakai car 42. So I'm going to end up with a dictionary with two values in it, and zap and Sakai car. And so the way to think about this is when the browser first comes into the server, it looks for the cookie. It might say, do I have this cookie already set? Now my application that I wrote is real simple. And then you are going to send the cookie back, and then the browser stores the cookie inside the browser. And then from that point forward, every time it makes a request, that comes in, and we can see this in the variable request.cookies inside it. So we really only have to set it once, although the code I wrote sets it every time, but it doesn't matter. Until it expires or until the browser closes, the job of the browser is to send that cookie back. Okay? So remember what I said? I said we're going to mark each browser with a different number so we can know which browser is which. That's exactly what it is. Now it doesn't always set it to 42. Usually it chooses a large random number, but we'll get to that in a second. So up next, we're going to make some sense of this by adding the back end part of this, which is the sessions, which stores all the data from request to request. So now we talked about cookies and how the server can set cookies in the browser and how the browser has to give it back. Now we're going to actually do something useful with it, and that is we're going to build sessions. And sessions is a place on the server where we record things like this user, such and so of user has logged in. So let's take a look at this. So inside the server, there is some code that we've enabled in Django called session middleware. And what it basically does is it kind of grabs every incoming request right before it comes in to urls.py, and it sort of injects itself before urls.py runs. And what it does is it uses the particular cookie value, maybe 3e, comes in as a cookie, and then it actually grabs the particular session and associates it with our request. And so by the time you're coming into one of your urls.py, one of your views from urls.py, what you find is the cookies have all been set, the session has been set up, it's made a session if necessary, it's looked up an old session if necessary, and so there's a whole bunch of sessions, and these sessions are stored in the database or on files or other kind of places, and there is pretty much one session object for each distinct browser that's out there, and we look them up by knowing what the cookie value was that we set it. And so one of the things the session middleware does is if it doesn't see a cookie coming in, it actually oh, well, I'll pick a large random number and then I'll send the cookie back. I will create a new session and I'll send the cookie back, and then I'll be able to look that session up on all of the future requests. So usually we just go ahead and start sessions when we meet a new browser. It's simpler. I mean, you can sort of sometimes delay it to save a little bit of resources, but often for most applications, right away you start using sessions, and then later you've logged a person in. You are going to mark each browser with some unique random number, and then when that cookie is sent back to us, then we can reassociate the session with the incoming request. So Django middleware handles the creation, deletion, the inserting of data, the deleting of data, and the updating of data in these sessions. The session identifier is a large random number that we put in a browser cookie the first time we meet a browser, and then we store using that same number a bit of data on the server, and then later when that cookie comes back in on an upcoming request, we basically look up the session data and then reassociate it with the request before we go through urls.py and into our views. So we have to enable this, and if you used manage or Django admin to create your project, this is already there. You can go ahead and look in your settings.py and you'll see that it's there. And you'll also notice that by now you've probably done a bunch of make migrations and migrates, and you see it making a session table. So there's all kind of defaults that are set up so that most of your first Django applications are set up to A, support sessions, and B, store sessions in the database, which is a fine way to go for small to medium-sized sites. So like I said, they're going to be stored in the database. You do this migration and you see that it's creating a sessions table for you in your SQLite db.sqlite3 database. So here we go. We have, as I said, out there, we've met these browsers. We've made a session object in our database, and we've put a cookie in each one. So there's some kind of a cookie that they're all named the same. So we'll name these cookies sesh ID or something. And so what we've picked random numbers and we've marked them. And so what happens is that a browser comes in, a browser sends a request in, and they send their cookie along with it. The Django middleware looks among all the sessions and then connects it up, and then it does the request. So there's many browsers, each with a different number, and then there's many sessions, each with a different number. And part of connecting is creating it. Now, if we look at this from the point of view of one browser and one session object, one session storage area, at some point we come in and it reassociates the session, and we're doing some work and we're writing some stuff into the session, and then we respond. We go to another request. We can read what we wrote. So we write stuff into the session, we can read it from another one. And then here we can read that same information. And then here we get a post, we read a bunch of information, but we write some more information. And so you can kind of think ultimately, just sort of at some level, relax about all the detail and realize that this session is a variable that lasts across many request response cycles. The cookie variable sort of also lasts across many request response cycles. The get and the post data, they vanish. So the get data for each one, you use it and you consume it or you store in a database, but the get data from one request is not available on the next request. So we have to use things like sessions sometimes to store little bits of information so that in a later request we can get it back. So the request object has this little attribute called request session, which is basically a dictionary. We can put keys in it, we can delete those keys, we can update those keys, we can call .get and retrieve a key to see if it's there, etc., etc. And so in a sense, we just take request.session and treat it as a magical dictionary. Now, we have to remember that each browser has its own dictionary, but when we're in a view function, we're only dealing with one browser, and so that session is the one associated with that browser. So it's this persistent interface, persistent data that lasts across all these things. So here's a real tiny view function, and you can see in this view function what we're going to do is request.session. This is where request.session is where you see the session data. It's basically a dictionary, so we can say .get. Then we have a key, and we have 0 as the default, num visits is the key, 0 is the default value, and then we're going to get that and add 1 to it, and then store that. And this is kind of like how we do counting. If we get it, if it was 4 before, we're going to go to +1 and get to 5. If it's not there, we just set it to 0, so we set it to 1. So somehow num visits is either 1 or 1 more than what was previously there. And so then what we see is we see the line that actually just stores it back into the session. That's it. It's a dictionary. It's a magic dictionary. It existed before it came in, and we're just going to leave it there, and somehow magic things take care of updating all this stuff. And so the other thing that we're going to do is we're going to have this go up by 1, and if it gets over, we're going over 4, then we're going to wipe it out. So this will count 1, 2, 3, 4, 1, 2, 3, 4. And well, actually, yeah, 1, 2, 3, 4, 1, 2, 3, 4. And so this del is just the standard Python syntax to remove a entry from a dictionary, and then we just kind of print out the number of visits in our little string and our response. And so if we go, we start, we have no cookie. That means that we also then have no session. And then we go into the session code, and you see that it has set a session cookie, right? So we see a session cookie called seshID. It's got an expiration date, which is it's not a expire when the browser goes away session, and it's got some big long random number. And so that is basically the session ID until we get a new session. And as a side effect of that, we've also stored the value 1 inside the session in the server and printed it out. So we came in, we established a session. We didn't do any of that, right? If we look at our view here, we didn't establish the session. All we did is grab something out of it, and that's because the establishment of the session happens in the middleware that's kind of outside of us. And so the middleware happens before our code starts and after our code is done. And so the session stuff is just taken care of when we do that. So view count is 1. And then what happens is when we just hit refresh, it's going to send the cookie in for that session ID. It's going to load up the session that's GJ2233, and then our code is going to add 1 to that number and store it back into the session, and then it's going to be 2. And if we hit refresh, it would say 3, 4, then it would do a reset and be 1. And so in this code, we just kind of say request.session and put stuff in it and read stuff out of it. And the cookie is the thing that looks that up. Now, if we wanted to take a look at what's in the session table, it's really just a session, and you can see that it gets created by your migrate and your make migrations. So we can go right into the database. We can ask for the tables. We can see the Django underscore session, and then we can say select star from Django underscore session. And so that will show us the data that's there. And so what we're going to see is the key, which is that session key, and then a time, and that's used to expire the session because these sessions don't last forever. The Django middleware kind of cleans these up after a while. Otherwise, you'd have sessions that just lasted forever and ever and ever. And then the actual data is this big, long string. So what this is this is actually an encoded string. And if you really want to look at it, it's encoded using a technique called base64. And there's a base64 parsing library. Base64 is a way of taking arbitrary data and encoding it in basically letters and numbers, upper and lower case. It's a little less dense. I mean, it kind of expands. It's not like a compression. It's the opposite of compression. It expands it, but it expands the data when it's encoded into base64, but it also means that then you can store it. You don't have to worry about any special characters, because sometimes when you're going like pasting, single quotes and double quotes mess up, all that kind of stuff. By saying, here's this string, I'm going to encode it in base64, I basically am guaranteed that there will be no weird characters that will cause some kind of problem farther on down the line. So if we take a look at our thing and we grab the little thing that's the base64 encoded variable, if you decode this, we're going to base64 decode it, you see that ultimately it's just kind of like a little key value pair that looks pretty much like a dictionary. It's a serialized version of a dictionary. It's a dictionary that has been put into a serialized form. And it's in also JSON format, and so we can actually sort of tear this apart and use the JSON library to load it up and see what we've got. So So that's there. You don't have to worry too much about that. It's just somehow this big long thing is being read and written and read and written on every request response cycle. That is certainly read on every request response cycle, and it's written when you modify the data in the session. So this has been a quick set of lectures. We talked about cookies, a way of marking each browser with a big random number, and then sessions, which are a bit of data that's stored in a database indexed by that large random number. And then each request comes in, we get the cookie back, and then we look up the session. The data, session data, key values, key value pairs, basically a dictionary, is all stored in there. And so we talked a little bit about how we do request.session in Django to implement, to access session capabilities in our Django applications. Hello and welcome to our lecture on data modeling. We're going to have a couple lectures on data modeling. This first one is sort of the one-to-many, which is the easiest to understand, and then we'll have another lecture on many-to-many. Just to give you sort of, we're still sort of building a Django application one piece at a time, and we haven't built a whole Django application. But basically, we're really focused on model.py and a little bit more on admin to inform. So model.py is where we define the structure of our database, and we see this database through data models, data model objects, and we can register our data models in admin.py. There's not too much in this admin.py. But we really, and so we're going to be talking to things like the shell, or you can even run scripts in here. So the whole thing in this lecture, we're not talking much about the routing or the views or forms or templates. So we're really focused down in this area of our Django application. And it's okay, we'll get to the rest of them. And we're just kind of talking about the data modeling now. So I came to databases late in life. I saw them a little bit in grad school, which is a very long time ago, and I didn't like relational databases much. And I went to a job, and I had to learn relational databases for the job, and luckily I actually was pretty advanced programmer at that point in time, and so they taught me how to do data model design, and I picked it up really fast, and I totally fell in love with databases. And so model design is a interesting problem to solve. The basic idea really comes down to efficiency of storing and retrieving data, and it just comes down to, like, if you build an online application like Facebook, and if you're not clever about how to store your data, and somehow every time you logged into Facebook you had to read all of Facebook's data to find you log in, it would really literally take you 2,000 to 3,000 hours to log into Facebook if it had to read all of its data. Now obviously millions of people log in per second in Facebook, and so obviously they're a little faster than that. So somewhere between, you know, days and days and days to read the data, and can read the data a million times a second. In there is where databases win. And so at times, it seems like when we're building a data model, you're like, oh, this is so difficult. Why are we working so hard? And the answer is, you just can't scale. I mean, you can read through your data for simple data mining things, but databases are really important. And especially when you're building interactive online applications, speed's important. So it turns out that, like most things in database, you can learn the basics pretty quick, and the rest of it is sort of an art form that you learn as you go. And so the goal is to figure out the data that you want to store in your application, and then draw a picture spreading that data across multiple tables and then creating links between those tables. So you kind of start with a sample data set. Now this is where we're going to end up, and this is the model for the data for this local library application that we're building, and this is the thing we're going to keep coming back to over and over. So this is the destination, but we're not going to hit this destination. We're going to start more with the data. Now, different applications, when you work at different organizations, you're going to find that the data model is very important. So this is the data model of my auto grader, which is based on a framework I built called Sugi. And so if you were to learn this thing, early on I say, oh, and here's our data model, and here's how we store stuff, and here's this, that, and the other thing. And this data model took a lot of time to get right, and it's a real important part of the application. And another project I work on is called Sakai. It's a learning management system that's open source. And you know, this is a tiny fraction of the data model, but if you want to work in this application, you want to improve something or add a feature, you got to figure out this data model, because where the data goes. It shows up kind of flat in the user interface, but eventually it's stored in very specific locations and linked. And that's why you see all these little boxes, but then lines. The lines are also the links between the various tables. So there's a whole bunch of theory about database normalization, and it's important. It really is. And if you take some time, go ahead and read about it. First normal form, second normal form, third normal form, version A and stuff. I'm not really into the math. I don't really want to explain the math to you. The key thing about database normalization, ultimately, that it can be sort of distilled down to: don't replicate string data. And what I mean by string data is like names and URLs and things like that. So in a system, ultimately, if my email address is stored in text in that system, it literally should be stored once. There should be no email address, email address, email address. What you need is to have the email address one place, and then kind of give that email address a number, and all the places you want to indicate about that email address, you use the number. And so these integer numbers are the key. So we create keys, which are the lookup handles, and then we point to those keys. And we use integers to make links between the tables, because integers are fast. They're the thing that computers understand better. Computers understand and move integers around. They use less data, they calculate, they compare really fast. And so integers are very important. So up next, we're going to take a look at some example data, and then we're going to design a data model for that data. So now let's design a data model. Usually you start out with a user interface that, if we're going to build an application, you're going to end up with a user interface. In this, I'm not going to really start with a user interface. I'm going to start with like a spreadsheet view. And if you've ever done something like tried to organize your music collection with a spreadsheet, or a video collection with a spreadsheet, or you find that spreadsheets are super convenient because you can scroll around and do stuff. And you've learned SQL. You can go into various cells with SQL, rows and columns, and update and do all this stuff. But you find that after a while, you start repeating yourself in spreadsheets, and you find it's really difficult, because it's really easy when you're putting data in to copy, paste, paste, and put the same stuff in. But then what if you want to change it? And this is where this vertical replication, or the replication of data in multiple places, is very bad. So here's kind of an exploded table view of that same data. And it's okay. This is the data that we've got to do. And so if we look at the use cases of our application, what we see is there's a series of books. Like in this course, Wisdom of Crowds is a book, Introduction to Networking. These are all books coming down here, Unlocking the Clubhouse. So the first column is titles of books. The second column is the ISBN. And then we are sort of keeping track, because we're a library, and so we might have more than one book, and we're going to call those the book instance. So instance 1, instance 2, instance 3. Each book, each physical actual book, so you might have no physical books actually, or you might have one physical book or 5 physical books, and each physical book might be checked out and have a due date. And so we have a status. And then we have something like, say, the language of the book, or the genre of the book, or who wrote the book, right? And so that's kind of the data we're going to represent in this application. Now, when you're looking at this, the first thing you do is you go like, anything where you've got vertical replication is a problem. And so you've got to be careful. So you look for vertical replication. And the places that are problematic in this table view of all of our data, like the status, the language, the genre, you see the word think. Those are strings, right? They're not numbers. Okay, Wisdom of Crowds, Wisdom of Crowds, Wisdom of Crowds. And the problem here with Wisdom of Crowds is that there are 3 instances of the book, but then because we've got this all in one row, one table with just a bunch of columns and not multiple tables, well, we have to replicate the name Wisdom of Crowds 3 times so that we can represent the 3 instances. The same is true about the English language and the genre and the author name, right? These are the same authors. Okay, so this vertical replication is your first clue that says that you've got to come up with a smarter data model than just this. And so the idea is you're not allowed to put something like the string EN, English, in more than once in your whole database. So what you have to do is you have to split this all out. Somehow you have to remove duplication by making a language table, a book table, and an instance table. And so in the book table you only put Wisdom of Crowds once, and you only put the English language in once, and Spanish in once. But then the problem is, okay, somehow we've taken this data and moved it from one big long bunch of columns to 3 tables with sets of columns. But we still have to represent all the original data that we were working with before. We have to represent all that stuff. And so this is where we have to be able to make connections. And this is the essence of relational databases, and that is they don't replicate data, but they make connections from one data item to another data item. And so what we're going to do here is, in the case of the Wisdom of Crowds, we are going to have 3 book instances, but somehow they all point to one book in the book table, right? And so we have 2 books that point to the English language, and one points to the Spanish language. Now this seems like, wow, that wasn't such a big deal, but when you do millions of records, it actually matters. It's the string data that gets you in trouble and requires far more scanning and far more storage. And another thing that happens is when you follow this rule of only one copy, well, what if we wanted to turn this to uppercase EN or something? That means as long as the data is linked rather than replicated, that means you're only changing one copy, okay? So the replication has a performance advantage, has a storage advantage, and it has a modifiability advantage when there's only one place. If we mistakenly misspelled the title of Wisdom of Crowds, it's easy, we fix it. It's not in these other tables. Whereas if we misspelled the Wisdom of Crowds here, we have to go find on the top one where it's just all one big long spreadsheet. We got to go and like do a search and replace. But what if that's in a different column? And so the idea of getting to the point where we have unique rows and we connect those rows. Now, I haven't told you much about how this magically works. I just said we can draw some arrows. And so by drawing those arrows, we got to show you how those arrows get drawn, because that's really important. So this is how you start drawing the picture of your database. And so the kind of relationship we're going to have between tables is like a many to one. So when we say many to one, what we're saying is that there is one English language entry and then there are many books that go to it. So that's a many to one relationship. So it could be just one, but it's many. And if we look at the data model that we see from the Django example from the Mozilla Developer Network, we can look at this and we can see here, right? This connection between the book table and the language table has 2 ends to it, and it has a direction to it. And one end says 0 ... and the other end says 1. So this is many. 0 ... means a number between 0 and infinity, including 0, which means it's possible for a book not to have a language. We call that null in database concept. So there's a book with no language, or many books can have one language. So there's one language, English, and there is as many books as we want, including potentially 0 books, right? So we might have a language that has no books in our library with that language, and that's okay. So in this one, between book and language, it's okay to have 0. So 0 through infinity on the book side of the relationship and 1 on the language side of the relationship. If then we look at the relationship between the book and the book instance, now remember what the book instance purpose is to record the fact that we have multiple the actual physical copies of the books that we have. And so we might have multiple copies. And so if you look at this, it's pretty much the same in that there is any number of book instances from 0 until infinity. And you could have a book in your book table for which you didn't actually own a physical copy, and that'd be okay. We would know things like what its author was, what its genre was, etc. And then we would buy a copy of said book, and we'd add a copy to the instance table, and then we'd link that into that book. So again, you can have 0 book instances, 0 through infinity book instances mapped to a single book entry. Okay, and so this little legend, 0 to infinity to 1, is how we read this table. And you will see database tables that have different syntaxes, but they all are capturing the same thing, and that's the cardinality, or the number of things at each end of the arrow. So up next, we're going to show you how to actually physically store this information in the database. So far, I've been just sort of saying, and there's an arrow, but we have to have a way to actually store it in the database. So now what we're going to do is we're going to talk about how we can represent links in a database. And so up till now I've just been drawing arrows and just assuming that you know how to do them. And so here's some arrows, right? We got some book instance rows that can somehow magically connect to some book rows, and some book rows that can magically connect to a language row. And so there's a way that we do this, and we put what we call a key column in every one of our tables. Key column. We call this the primary key, and we often call the name of the column the ID. There is a way in the database to make it what's called auto increment and primary key, and index it so it's really fast. And so that then becomes the handle. The primary keys are like the destination endpoint of the arrows, right? So that's how we say English becomes language number 1, and Wisdom of Crowds is book number 1, and Introduction to Networking is book number 2. And so the ID is something that we then can use throughout the rest of the system. Integer replication is not a problem, okay? And so then what we do is we put columns in that we call foreign keys, right? And so those foreign keys are the starting point of the arrows, right? So book underscore ID. Now by convention, we name these by the name of the table, followed by an underscore, followed by the word ID. These are called foreign keys. Foreign keys. And so by having a foreign key everywhere we need to start an arrow, and a primary key everywhere we need to end an arrow, now really we pretty much put primary keys on every table so that every row of every table has a primary key. Now in this example, I've just got one foreign key per table, but you can have more than one foreign key per table. There could be another column here that points off to another table. But that's it. That's how we do it. We just simply add these integer numbers, and then we kind of maintain them and put them all together. So like I said, the primary key is that column that we add, and that is our handle for the rows. And then the foreign key is the column that we add to a table so that we can point to something. So basically, once we create these foreign key columns and the primary key columns, we start being able to build, using these links, we can build the links that replicate the data model that ends up being our picture, okay? And so that's how they work. Up next, we're going to talk about how we represent these links in Django. So we've talked about how we reduce replication by moving data from sort of one table with too many columns into multiple tables, and then make links with primary keys and foreign keys. But we're really not going to operate at that level because this is a Django class, and we're going to do this in Django. And so we use data models in models.py to do this. And so a lot of the model field types are characters or numbers or dates or long text fields, etc. But some of them are special and used in this one-to-many, foreign key, many-to-many fields. These are the fields that we use to do the linking in our Django data model. And so we'll take a look at how these all work. So if we have our book instance that links to our book table, and then our book table that links to the language table, we end up with special little lines in our models. So most of this is pretty familiar. We got a language, it's got a name. Now one thing about Django is it automatically adds the ID field, and that's kind of nice. So you just assume that everything inside of a data model, every one of these three tables are going to have ID fields. And we don't even talk about the name of the foreign keys, even though Django names them the way I just showed you with the lang underscore ID. We have just a regular old thing, so lang is suitable as a destination for a link because it has an ID column automatically added by Django every time. The book table has an ID column, so it's suitable for the destination of a link, but then title and ISBN are there. And then there's this language, and that's the first one. And so this is where we're actually modeling the need to have links between the book table and the language table. So we're putting starting at the from, or the start of the arrow, and we're saying we need to have a language. But the language is not a string, it's not a number, it is a foreign key. And it's a foreign key into the table called lang, and this table called lang matches that table. And then we have a couple things. I'll talk about on delete in a second, and then null equals true is whether or not it's required. And so what it's saying when null is true is we're allowing emptiness. So that means it's possible to have a record in the book table that doesn't have a language. And so that's what we're saying when we're saying null equals true. The instance table points to a book. It's a foreign key to the book model, and it has a do back. Now the status was in there, and so I sort of shortened it a little bit, but we have a foreign key that points into it. And so again, we're defining where we have the beginnings of the arrows, because the ends of the arrows is kind of implicit. Django gives us sort of the primary keys for each row in these models automatically without us having to say it. But you can put it in a Django model if you want to override the name of it, but if you just want a column called ID, which everybody pretty much does, you just leave it out and Django puts it in for you automatically. Okay? And so again, you see this from the point of view of the data model, where we have the arrow between book and language, that's a many to one, and then a book instance to the book is a many to one as well. And so those foreign key links represent the arrows in this data model. Now, just to sort of review, you might have done already some of these migrations. So once you edit these data models and you get them right, you have to do a two-step process to get them so that your database reflects these models. The first one is you have to make migrations. And so the way the make migrations works is it looks through all of the applications that are registered in your settings.py, and for every one, it checks to see if the data model has changed since the last run of make migrations. So make migrations actually creates files in your application based on the models.py. And it's a series of files. Like 001 here, that's the first one. There might, if we changed it and then run make migrations again, there'd be an 002. And what it would do is the 002 is evolution up beyond the 001. Now the migrations are portable, okay, in that they're not specific to the MySQL database, the SQLite database, etc. Now the migrate reads those migrations and then updates the actual tables in the database. And so the migrate is mapping the portable representation of what's supposed to be in the database into the actual physical representation in the database. Now you'll notice if you run these both twice, once they work, they'll say no changes detected, because in the case of the make migrations, it looks at your models and then looks at what's in the migrations already and says it's a perfect match. And then in the migrate, it looks at what's in the migrations and what's in the database table, and it says everything's there, everything's been done. So this can be confusing, because in my documentation I'll say run a make migrations and you say no changes detected. Now there's another reason why you might get no changes detected, and that is that you have to add it to the settings.py file before you can, it's going to be detected. So you might have edited a model.py file and changed it, but if it's not, the application is not in the settings.py, then it won't be detected. So the make migrations is reading through all the applications listed in the settings.py, checking for differences, deviations between models.py and the migrations. It might be a little easier just to show you these things. That's coming up. I'll show you those in a second. If we look at what the migrate does, the migrate creates the SQLite file. And so we can take a look at this file. You don't have to, but you can take a look at this file after you've run the migrate. And you see, so I have a tables book 1%. That's actually a wildcard, because the like statement, that's like the like statement in SQL. So that says, show me all the tables that start with book 1. And you see that there's 3 of them, book 1 underscore book, book 1 underscore instance, and book 1 underscore lang. Book 1 is the application, because Django has project and then applications within project, and book 1 is the application that we're doing. And then instance, book, and lang are the three models that we've specified in our database, in our models.py. So if we take a look using the schema command of book 1, we can see how the migrate statement produced the table. And so we created a book1._book. It has ID, auto increment, all that stuff from the SQL stuff. It's got a title, it's got ISBN, and then it's got this lang ID. That's the foreign key. So it's actually building the foreign key the right way. Now in SQLite, there's one way of building foreign keys. In MySQL, there's a different way of building foreign keys. And so that's all something that the migrate operation understands how to build. And if you look at the language, you just see that there's an ID column that's automatically produced, and then a name. And then if you look at the instance, you see an ID and a dude back, which is date. And then you see the book ID, which is the foreign key into the book table. And so you can kind of see how these tables implement the links as described in the picture. Now, I was telling you that about this on delete. So the problem is what happens when you have a row in one table, like in the book table, that's pointing to a row in a language table, and you got records that are pointing there. So you've got two books that are pointing to English in this situation, and then you delete the English row. What happens to the rows? And there's a couple of different things that you can do, but the two common things is cascade, and what cascade says is that you're going to delete all the rows. If you delete those rows, you're going to delete all the rows that have the matching language ID. And set null basically instead says, oh, that's okay, we're just going to wipe out these and make them null. And in this in this language, if we delete a language from the language table, we probably just want to set it to be null. Okay, and so if you look, you'll see that the relationship between the book and the language, which is right here, if we delete one of these things, we set it to null. We set the corresponding language to null. We just throw away these links in a sense, and that's okay, because books are allowed to not have languages. Okay, and so languages are allowed to be null. Null equals true. Languages are allowed to be null. But if, on the other hand, we get rid of a book from our books table, then we probably want to wipe out all of the instances that are related to that book. And so that's why we in here say on delete cascade in the book foreign key entry. And we don't say null equals true. And so set null requires you to be able to say null equals true. So you have to say, I am willing to allow nulls in this column. Oh, and by the way, if the thing that this column points to is deleted, then set it to null, which means don't delete the row. Cascade means if the thing we're pointing to is deleted, then delete this row, because we don't want inconsistent data. We don't want those little things pointing off to absolutely nowhere and making absolutely no sense. So up next, I want to go into a little more detail on models, migrations, and databases and how they work at a bit of a low level. So now we're going to take a look at the kind of Python code we can write to manipulate these data models. So to do this, we're going to use what I call the Django shell. Now the Django shell looks a lot like the Python shell, except that there's a whole bunch of stuff preloaded. You can't just run Python 3 in interactive mode. You see the chevron prompt. On Linux you see a bracket prompt. It's the same shell, but in the Django shell, what happens is actually reads the settings.py and goes and finds all the applications in settings.py and preloads the applications and then gives you a shell. So it's like there's a bunch of things that happen that's not just a shell that are done before you're in the shell. And this statement of from book 1 models import book lang instance, that wouldn't work if you just ran the Python shell by itself. That's because the book 1 application was loaded by Python 3 manage.py shell. After that, you've got all these things preloaded, but then you can pretty much run any Python that you want that messes with all of your Django classes and objects, etc., etc. So let's take a look at the kinds of things that we can do. So if you remember, our data model was named lang for language. And so we can create a new object in memory with lang parenthesis name equals quote en quote. And that basically says, give me a new language object and set the parameter, the attribute name to be en. and give that to me back in a variable. That's an object-oriented constructor. We're constructing an object. Now that doesn't store it in the database. That simply creates it in memory and gives it back. So it's a Python object with an attribute. It knows it's a language. Now the save method, z.save, that is the thing that says, you know what, I've got this thing in memory, please persist it to the database. Write it, transmit it to the database, and come back. Now what's cool about that is this ID column, that's been set at that moment. So we can say, what ID did we get? So remember how every row that we put in a model gets an ID value, and we're going to use that ID value as the handle to point to. So this is the primary key, which is the way we point to a row in a table. So then what we can do is we can make a book, right? So we made a language, and we know what its ID is. Now we're going to make a book, and it's got like a title and ISBN. And what we do is we say, and the language is Z. Now Z there is that variable. Now we don't use the ID. Django knows all about how IDs work, and so it knows when you're saying lang equals Z that it's going to make a lang ID and put the ID of the language row in. Foreign key, all that stuff's just done. You just have to have a variable that has an ID value and pass that in. And so what that's doing is that is making a book and then connecting it to a lang. Right? Now that's also not saved until you save the book. The book is now transmitted to the database. It has a foreign key in it. It gets its own primary key, so it's primary. It's the first book that we've inserted, so its primary key x.id is 1. And then we can make an instance, and the instance needs a due back, which is a date, and then it needs which book it is, and we use that variable x to indicate which book that we're talking about. So that's just creating a link from the book instance in memory that we get back in the variable a. It's a book instance that points to the book it's in the variable x, which is py for e, ISBN 42. And then we save that, and that has an ID. So now we have created a language record, then we created a book record that linked to the language record, and then we created a book instance record that linked to the book record. Okay, and so that is, you know, this whole linking thing, right? So these are the pointers, and what Django's doing in this situation is Django's trying to hide from us the whole idea of the foreign keys and the primary keys. Other than me asking what the ID is, it's not really something you have to do. So all those asking for the IDs aren't necessary. You just say, look, I have a book, and its language is this thing. I don't know what its ID is. You should please make me a column and do all this magic stuff. So much of the bookkeeping of these one-to-many relationships or foreign key relationships in general in Django is just done automatically. Now, we can retrieve these and we can sort of walk down these things, walk through these things. So here we are again in samples, and we run the shell and we import our models, and we can say book.objects, and book is a class from our models. It's book1.models.book. And then a lot of the methods that we talk to inside of these classes are under the attribute.objects, which is, you could think of it as all of the rows in a sense, or all the objects in this model, all the rows in the table that lives there. Book objects, and then get is like, which one do you want? Get pk equals 1. Pk means primary key. I don't know, I think it would make more sense if we called this ID, but ID is the name of the column of the primary key is really just kind of a convention that's done 98% of the time. It's not required, it's not the truth, but it's so common that it might as well be. But PK really means primary key, which 9 out of 10 times is the column ID. So we're loading from the books table, we're pulling that in, and we're getting the row number 1 from the books table. So if you say what the title is, well, the title of that is PY for E. Now, there's a title, but then there's lang. Lang is that foreign key that points to the language. And so we can say x.lang, that is the entire language row, but x.lang.name is within that row, it's the name column. So we sort of walk down the little arrow and grab one of the elements out of that. So it's like walking from a book to the corresponding language row, and then pulling the name out of that corresponding language row. So I think that's a really pretty syntax. And it starts to make sense after a while. You walk through the little arrows. And this is why the picture of the data model is so absolutely important. Oops. And then, and so now we're going to go grab the book instance number 1, the first row of the book instance table. So instance.objects get pk equals 1. That says give me that first row, give it back to me in the variable y. What is the do back of this one? And then you can sort of walk it. You can say, I'm at a book instance, and I want to follow the foreign key to the book table to get me a book, and then give me the title of that book, right? So from a book instance, you can walk to the book table and then get the title of the book, and then we get py for e. So you see this sort of starting from one row, walking to another, the corresponding row that's pointed to by this relationship, and that's the essence of this. We're going to do this a whole bunch. By the time we come back to this will all seem pretty straightforward. So we've been working with the Django shell and typing commands in to insert records and populate fields and create the both sides of many-to-many and then link them together. And so some applications that we're going to build, you're going to put up your super social ride-sharing thing that you just built, and people are going to start filling it with data. But other times you're actually building a website for which the data is already known. You might actually be reading a bunch of data and putting it into a database from some source. Maybe it's an API, maybe you're scraping or whatever. And so you have some source of data and you want to put it into the database. And you don't want to put it in by hand. And so we're going to talk a little bit how you can write a script to load data into your Django database, into your Django models, after you've defined those Django models. And so we're going to actually take some CSV data, we're going to read it from a file, and it's just comma-separated values, and we're going to use the course person membership model from before, and we're going to say basically, here's a person with their email address, their role, which is instructor or learner, and then the course that they're in. And what we're going to do is we're going to write a script to read through all those things and then insert and populate. Because you gotta, when you're making a many-to-many, you gotta like put both sides in and then connect it together. And so the code will be in DJ Free Samples scripts manyload.py. That's the code to load it, to read this file, and then create it, put it into DB-SQLite, informed by the data model in the many-to-many example that I gave you with the course stuff. Okay, so that's what this is. Now, running scripts is part of a feature of Django called the Django extensions. Now, if you've already done this through when you installed DJ Free Samples and you ran pip3-r requirements.txt, you already put this in. But it doesn't hurt to go into your virtual environment and type pip3 install Django extensions and make sure it's already there. Because if it's not already there, then it will get installed. Otherwise, this whole script thing won't work, right? After you install it, you do have to put a little link into your settings.py. That's Django under Store extensions in your installed apps. And there's documentation on how all to do this. So that's the first thing you've got to do. Once you've installed it with pip, you have to pull it into your Django application. So when Django first loads up, which is python3 manage.py, at that point that says pull this in, pull all these other things in. All your apps, your extensions, the Django features you need, etc., etc., etc. And that's in the project settings.py file. So Django extensions won't work if you don't put it in this file. Now, if you're running on Python Anywhere, of course, after you edit this file, you gotta reset your web. But I think you probably figured that out by now. We wouldn't have got this far if you weren't resetting your web server on Python Anywhere. The next thing you do is within your Django project file, you make a scripts folder, and you put this file, empty file, touch is the Unix command to create an empty file. Scripts / /init__.py. This is just kind of a thing you do, and what it is an indication as Python is reading through these folders to say this folder contains modules that are suitable for importing. And that's just a signal. And I think later versions of Python make this less important, but we've always put this in. So if you're going to put like classes that are intended to be imported into some other application, we always put this empty file underscore init dot two underscores init two underscores dot py. So touch says make an empty file of this name.
So let's take a look at our files inside of the DJ Free Samples folder. So I am currently in the DJ Free Samples folder, and it's the main folder. The settings are in DJ Free Samples. We're also in the same folder as the manage.py because we're going to be running commands, the manage.py commands. We're all playing with the folders cats and in the scripts. So the cats is where we have the models. Cats models.py. So we have two models. We have a cat model that has two normal fields. One's a nickname field that's up to 200 characters. The weight field is a floating point number. And then the breed is a foreign key into the breed model. And the breed model, other than its indexes, and I mean its primary key, has one field called its name. And of course, you want to have run your migrations. You probably already did this. No more migrations to run. If you run a migrate, it'll say I'm all taken care of. Because these were here when you first checked this out. So the migrations, yeah, so we're good now. So the data is in a file called cats/meow.csv. And comma separation, it's got a heading at the top, name, breed, weight. We're going to skip that in a second. And then you've got the cat's name, the breed, and the weight. Now the key problem here is from data modeling. We've got some vertical replication. Manx, tabby, sphinx. So we can't create a whole bunch of breeds. We can't just put these in as strings. So we're going to create a many-to-one relationship, and the breed is going to be in a table. Yeah, cats. Back to the model. All right, we're going to put each breed is going to go in uniquely, and then we're going to get a primary key for that breed. And then when we insert each cat, we're going to reference or point to using a foreign key. Point to that breed. So let's take a look at the scripts. Now, just the way this works is you've got to put these scripts in a separate folder. And the reason is so that this import statement works. So that has to. So there's a whole bunch of stuff to load Python up, but then load your Django application up as well. And once your Django application is loaded, then this cats models exists, and we can import the breed. And if we look through the code, we're going to open the file cat/meow.csv that we just looked at. We're going to use a CSV reader. Now you could do this with a split and commas if you really wanted to, but we are going to skip past that header. Remember the header, this was the first line. We're going to skip past that. And so we can run this over and over again. We're going to just call cat objects all delete, and same for breed, to get rid of any data we put in, because it lets us run this over and over and over again. And so now we've read the first line, so we're going to start the second line, and then we can just iterate through the remainder of the CSV reader. I'll print the row out. And this line here that says B created equals breed objects getter create name equals row 1. So the first thing is this row 1 is going to be, in this case, Sphinx for the first one, and then Burmese for the second one, and Manx. So this is a pretty cool, this getter create method is a pretty cool thing. It's saying, if there is a breed with a name of Sphinx, get it for me. If it is not, make it for me, and then get it for me. And that whether it's created or retrieved, it comes in this variable B, and created is just if you want, it returns a true or a false as to whether it was newly created. Sometimes your code is more sophisticated and wants to know if it's the first one. So then we have to create a cat object. And let's just take a look via cat/models.py to recall that the breed has a single variable, a single field name, and cat has nickname, breed, and weight. But breed is a foreign key. It's this special kind of thing. And so what we're going to do is we've got a breed object, in that was created with, in this first line, Sphinx. And then we're going to make a cat object. And the row sub 0, which is, in this case, Abby, is the nickname. The breed is a reference to the breed object, which is in this variable B. So breed is the field inside of the model, inside of the cat model, and then B is the actual row that it's pointing to. So that's a real live saved row in the variable B. And then weight is the third column, which is in this case 6.4. And you know that just by calling the cat constructor, we do not actually store it, but you have to call c.save. And then this loop goes round and round through all the readers, and eventually it creates all these things. So let's go ahead and run this. Python 3 managed py run script. Cats load, I think. Hopefully I got it right. Oh, yeah, maybe I should put a T in there. There we go. And so it's successfully loaded. This is just printing as the rows are read, but it's all loaded in. Now, we can verify this by saying SQLite 3 db.sqlite. That's a database. Now, I got to be in the right folder for this to work. And I can say .tables to see what the tables are. So kind of going down to SQL, and you can see the cat's breed and the cat's cat. So I'll say select star from cats underscore breed. And these are the breeds. And they're the primary keys. So Sphinx is 26, Burmese, Manx, and you'll see we've only put them in once. And then I'm going to say select star from the cat's cat, limit 10. And so we've got Abby with a weight of 6.4 and a breed of 26. So Abby is a Sphinx, right? And then Annie with a weight of 7.6 has a breed key of 27. And so there you go. And so now you see that you've built those. If we say select count star from cat's breed, there was only 6. And if we do that same thing for cat's cat, we have 104. And so there you go. This is a simple way of running a script and reading some stuff, and this get or create is a wonderful way to allow yourself to do many-to-one relationships and make sure that you're not doing vertical replication in a column. So the get or create is kind of really doing almost all the work for us with the vertical replication.
Our next topic is to talk about login and logout. Now, just in general, I have this GitHub repository called DJ Free Samples, and every once in a while you ought to see if I've found some bugs and fixed them. So go over to your samples and do a git pull. So every once in a while, just do that. So Django, like in lots of situations, comes with a built-in login, logout system. There's lots of ways to do it. You can read up on it. It has a way to create users, has this nice admin interface. And so one of the things we like about Django is that we don't have to build some of these basic maintenance things. It has permissions and groups. We use this in the local library application, but we're not going to use that so much in our applications. And passwords, etc. And it has a way to store these things in various techniques. And so the first thing that you'll probably encounter when you're doing this is to create a super user. And so you have to log into your system, you create a super user, give it a name, an email address. The email address is for password recovery, even though you can log in and you can change your super user password anywhere. And then you do it. Now there's a great XKCD cartoon for so many things. This is, one guy says, make me a sandwich, and the other one says, what? Make it yourself? And then says, SUDO, make me a sandwich. And the other person says, okay. So what sudo means is it's a Linux command to switch to the super user and do a command. So if you don't have permissions to do a command, you can say sudo a command. And so that's what this xkcd. So that's what we call a super user. That's the user that has all permissions, doesn't need to get any special permissions. This might be a good time to review what you're going to do when you wipe out your database. When you create that super user, it just adds a row into a table in your DB SQLite, and you can wipe this out anytime. That's why I like using SQLite for development in Django. If you remove it, you've removed all the tables, all of the tables created by migrations. The migrate command is what creates tables. The make migration actually creates migrations with your Python code. So if you're going to start fresh, you got to remove the DB SQLite file. That's got rid of all your users, all your super users, any data you've put in, it's gone. And then you have to wake it back up with a bunch of empty tables with a manage.py migrate, and you'll see all those things. Lots of lines come out at that point. I didn't include them. And then you're going to have to create your super users again. So just if you wipe your database, you got to recreate your super users. Once you have a super user, the rest of the users are put in using the admin interface. You just go in and among all the other models that you might have in your application, the groups and the users are just models. They're models that happen to be built into Django, and you don't have any responsibility for building them. And so, like I said, the groups and permissions is useful, and you can read up on that, and maybe your application needs to use those. But for me, I pretty much just make users and call it good. Later, we're going to learn how to use like social login. So we'll use GitHub to log people in, so you don't have to create any users other than your admin user. But in the short term, we're just going to use what are called local users, which are stuck in the database, kept in the database, and easy to create, easy to maintain. But you tend to have to manually maintain them a little bit. So next, we're going to look at, now that you've got a user, how do we, in our application code, log in and log out users? So now we're going to take a look at what we do with Django to handle logging users into and out of our application. So we talked about sessions recently, and making a session is not the same as being logged in. Logging in actually changes data in the session. Logging in general, the most basic way of logging in depends on the existence of a session, and logging in is putting data into the session about the current user and their name and their email, and then logging out is removing it. In the session, you could have multiple users, log in with one user, log in with a different user, log out. If you're just in the same browser, you're going to end up with the same session, just associated with different users. So remember, sessions and login are not the same thing. Just like cookies and sessions are not the same thing, sessions and login are not the same thing. But they all build on each other. Sessions build on cookies, and login builds on sessions. So to make this all work, you have to add to your installed apps all the Django support for all this login and logout stuff. Now, if you automatically built your project and you got a settings.py that they're going to just put this in automatically. So this is just so you know when you're looking at it where it is that all this magic functionality comes from. It comes from this installed apps. Also, for the login and logout, you're going to have to add a path to your project-wide. So DJ for eSamples, DJ for eSamples, urls.py. This is not in any of your applications. This is in your Django project, and you add a path, and there's a bunch of URLs, and that gets all registered, and a whole bunch of wonderful magic happens at that point. And so that's how these URLs are activated in your Django project, so the applications. So the way we get the URLs to the login and logout features is we use the reverse. We've been using reverse all along. Reverse is the way we look up for a particular view. And in some urls.py, matter of fact, in that Django contrib auth URLs, in that there is a name equals. And so there's a view in there that they've got that we didn't write, and it has a name equals, and has name equals login and a name equals logout. And so we can do a reverse lookup like we would of any of our views that we might have. Say, give me the URL in this Django project for the view named login or the view named logout. And it's pretty simple. You could even probably hard code these, but maybe the route isn't exactly account slash, right? And so maybe you called them something else. And so that's why we use the reverse to look these things up. And so that's just a convenient way of doing it. Now, one of the things about logging in is sometimes you have an application and there's like a login button. But sometimes you just have pages that are protected by login. And then when you go to a page, it says, oh wait, you got to log in first. And then after you log in, you'll notice it typically just takes you right back to the page that you wanted to see. So you might bookmark a page when you're logged in, and then you log out, and then you click on that bookmark page, but that requires that you be logged in. So you're going to go to the page, and then when you're done logging in, then you want to come right back to that page. And so that's using redirecting, but it's redirecting after login is successful or after logout is successful. Logouts are almost always successful. And so there's a parameter that we can add, a get parameter that we can add, and it's the next equals, and what we do is we give it a path. And so here's a little bit of code that we're going to play with in my sample codes under the Auth-Z project, under the Auth-Z application. And so I got a bunch of views, and I'm going to give them some names so that we can play with them. So these are just the urls.py. So if you take a look in this main.html template, you see a whole bunch of things. You see this next feature in action. So here's a couple things we can do. So there is this user object that in a sense is passed in. You don't have to do anything to pass it in. There's this user object that sits there in your template context that's automatically. We'll talk later about how you can sort of inject into every template certain little things that you got to inject. But the system injects this user. There is an attribute called isAuthenticated, which is true or false, to say whether you're not logged in or are logged in. And so if we see it, we say, oh, what's their person's full name, user.email, user.id. User ID is the primary key. We might actually have later we'll have a foreign key that goes into the user table, and we need to know what the primary key of the current user is so we can populate our foreign key. So when we have a row and it's owned by such and so, we're going to actually put a foreign key into a table that we didn't even create. But the thing I'm talking about now is you can get a URL, that URL tag that's looking up a name of a view. Log out is the name of a view. Log in is the name of a view. And then we have this question mark next equals. That's the parameter to say when you're all done with that log in or log out, go back to this particular URL. Okay? And so that says go to the URL that's in the Auth-Z application, the view named open. And so that's one way of doing it. Another way, let's say in login, we're going to get the login URL and send ourselves back to the request path. Request is another one of these things that's dropped in automatically for us. That is the current URL of the view we're at. So in a sense, this is a contraction that says go ahead and go to login, and when you're back, come right back here. So login will log in and then redirect back to this page that we're on, whatever the page is, because this is going to be, this little main.html is used in a couple of my different views. So request.path is like come back here. So that's a good pattern to know, to just say log in and come back to this current path when you're all done. And so here's just a bunch of connections to this thing, and we have here's just all my links, and I have a couple of things. I have some no login required pages just to play around, and then I have one that's protected by hand in Python, and then one's required by a login mixin, and then I sort of dump all that data, and I think I showed you that one already. So here is one of them, right? I showed that. That's what this all looks like. You can see that these links have the next in there. This is how it turns out to be. You get accounts login. Oops, come back. You go to accounts login, next equals Auth-Z open, and that's basically, I'm in this file right now. I'm in that URL, and that says go ahead and log me in, and then come back to this URL, to the Auth-Z open. Here's an example of the logout URL with a next setup in it. And so up next, we're going to talk about not just how to get the users to go to the login page, but how to configure the login page. So now we've kind of understood a little bit about the user object and how we do things in templates and how we get at the URLs for login and log out and then how we redirect back to ourselves. Let's talk a little bit about the login page itself. And so the login page is something that's provided by Django, but it needs a template. And so what happens is we get to control the template. And we're going to go to this URL, the code behind the views, the code that looks up the password, the code that gives you errors. That's all taken care of. All the views are taken care of. And what we get to do is we get to describe a template that controls our look and feel. And so we can have a simple login thing or a pretty login thing, and we can have links to the rest of our application. And so we want control over our login page so it looks like it comes from our application rather than having it look like it came from Django. So I'm not going to go through in much detail about how this works. You have to create a template that can be accessed as registration/login.html. And remember that no matter which application in a Django project you're working in, those names are global. So for example, this name right here, registration/login.html, the fact that it's in my home application doesn't matter. And that's why we have this extra slash in here. So just because it's in the home application doesn't mean it has to be, the home and the registration don't have to be the same in this particular case. And so this is a template that if they just do a render, so in their view, in the login view that's somewhere deep in Django, they're just going to do a render to registration/login.html. You have this somewhere in some application because the templates are global. It's going to find your template and put that in. So within this template, there's a few rules that you've got to follow. They're going to send some errors, and there's errors. If the form has errors, you have to have some output that deals with that. If next, that's actually that next equals parameter. Okay, and so if the next is there, and you've come into this log, and this one's a little bit weird. If you have a going forward page, that means you came from a page and you're going to go back to a page. If the authentication happens, that means you've been logged in, you went to the page kicked you back because it's protected by more than just logged in user. Okay, so this little bit right here, this is a little bit subtle. If you're not logged in, that's kind of the normal case. Please log in to see the site. And then we basically create a simple form. We're going to post to the login URL. That just looks up the login URL. And we've got this context variable called form, and we can print that out. That form has the key, that form has all of the input stuff in it. We're going to talk about forms coming up soon. And so that's what generates this form here. Generates all this stuff right here. And so there could be a bunch of things in there, but the form is a variable created by the view that has all the input names and areas, etc., that it wants. So we didn't have to actually construct the form. We do have to submit, put the login button, we could put a cancel button, and we do have to pass the next back as a hidden field. Now a hidden form field is just like a text field, except that it doesn't show up here. And so that's in there, and if you were to view source, you would see that. And so that's after you submit this form, it needs to know where we're going to go next. So then if you're successfully logged in, it's going to log you in, say yay, and then it's going to redirect to whatever that next value is. And that's our way of, it's going to give us the next value inside this template, but we have to give it back to the view when we post back into the view. So like I mentioned, there's a whole bunch of data that we can get. There is this user variable. And that user variable has their full name, their email, and very importantly, the primary key of the logged in user. But these things are only defined if user is authenticated is true. You can access this user data in Python. It's in a little different spot. It's in the request. So I just changed the name of request to REQ. That's just a variable name you pick. I will generally always write it as request or REQ. And so the user information that is pretty much the same as what's in the template tag, template context user. User is authenticated. Their username, their email. I could have had rec.user.id if I wanted here, and otherwise it's not logged in. And then I just throw this back as a simple HTTP response. This isn't all that useful. It's just showing you how to get your hands on those values if you're in Python. So sometimes you're in Python, sometimes you're in templates. Quite commonly, you're in templates. So I've been talking about a view that requires a logged in user. And so again, imagine something where you're sort of reading your messages on an online system, and you bookmark the message reading URL, and then you shut your browser down, which logs you out of the system, and then you click on that bookmark straight to the messages, my inbox or whatever, and then inbox looks at you and says, you're not logged in. So I got to send you to log in, you finish logging in, and then you come back. That's what the next equals does. Now there's a couple of ways in views to write that kind of feature that basically says, this view is fine, but only fine for logged in users. So let's take a look. So one of them is checking to see if user is authenticated. So I have two views in here. One is, I'm going to protect it manually, and that's so you can see how it works, but it's really not the right way to do it. I mean, you can do it this way, but it's like, there's always a better way in Django, always a better way in Django. So here we have a class-based view, and we ask, is the user authenticated? If the user is authenticated, we just do whatever. Now, there might be a whole bunch of stuff in here. There might be a whole bunch of, but I'm just going to render the thing so that's a view. So I'm protecting this particular manual protect view. But if you're authenticated, you can see it, right? It doesn't do anything in particular other than dump a bunch of data out. If you're not authenticated, then I'm going to construct a login URL by calling reverse, say look up the URL for login, add a question mark, and then add the request path, which means wherever we're at, come back to it. So that's the next, and that's going to put next equals, blah, 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 blah. And then instead of returning a render, we return a redirect and say, okay, go to the login URL. So the way this is going to work is, it's going to come in once, right? You're not logged in, so it's redirecting. It's going to go out, but then it's going to come in back again, and this time the user is redirected in, so it's going to show you the page. So you end up going through this twice. Now, that's the bad way to do it, or the wordy way to do it. I mean, it's only 5 lines of code, but I don't like 5 lines of code. So there's this thing called a mixin, and a mixin is a class. The idea of a mixin is that, you know, we have kind of an inherited class. We inherit things that are like just a feature almost. So what we're doing is we're going to take our protect view. It really extends a view, but it's going to also add the capabilities of login required mixin. So login required mixin basically says to Django, if this is here, hey, I want to do this. Don't let the user into this particular view. Protect the view. So this is another protected view, but by simply including this little signal that says login required mixin, I've mixed this into my view, then it does all this work for us. So what'll happen is it won't even come in, right? It won't even come in if the user's not logged in. It will redirect and then come back and then let this code in the get run only when the user's logged in. And so this is by far the most common way to do it, is just called login required mixin, saving you from writing all these lines of code, right? So all these extra things, because do I remember how to do this? What if I write that 5,000 times in an application? It's really kind of silly when we've got login required mixin that takes care of all this stuff. And just to review, this is what that view looks like. It just sort of dumps all that stuff out. I use the same I use the same template for all of these views. So login, like many things in Django, is simple. It's easy. You add the things to installed apps and URL patterns. You make yourself a template. I didn't go into great detail. Django has great documentation if you want to get really sophisticated. What I tend to do is I get 1 or 2 templates working for login. I'm like, I want to use this one today or that one. So this is where like the sample code has 2 different logins that we're going to use. One is a simple local login, and the other one actually is a login when we're going to use GitHub to do our logins. You can get yourself get your URLs for login with reverse lazy, or the URL template tag. And then if we want to come back, we add an X parameter to those URLs. And then when we have a view and we say, look, this view is going to depend on request.user or the user in the user template tag, just add login required mixin, and then Django takes care of making sure that you can't get to the view unless you're logged in. And if you try to get to the view, it tries to let you log in. And if you are login successful, you come back to the view, and it's all transparent to you. And it's literally just one little comma thing in the create. So it's pretty simple. It's pretty awesome. I just want you to understand what's going on, because again, sometimes the fewer the lines of code to write, the harder it is to understand. Cheers. So up to now, we've mostly just talked about how forms work. We've been talking about how forms work across whatever programming language you're using or framework you're using. We've mostly talked about how the browsers treat forms, how we generate HTML to make forms, how posts work, how refresh works, how post redirect works, how CSRF works. That's, other than subtle details, those are topics that are true no matter what you do, no matter what language you're writing in or what framework that you're using. Now we're going to pivot a little bit and talk about how Django helps you do all those things that we just got done talking about doing. So if you look at this picture, you see that like forms are kind of in the middle of this picture. That's the final piece we're filling in. And forms are connected a lot of ways. Forms can be connected to models. They're used in the view and they're used in templates. And so they're a very powerful part. And all the things that we've been doing as abstractions, where we write a little bit of code and find lots of ways to reuse that code. Or we write some code that extends an object and then we add a little bit to it, and then we've got some very powerful object when we're all said and done. And so that's what we're doing here in forms. And forms can be used in views, they can be used in templates, and they can interact even with models. And so we're going to talk a lot about forms. There's a lot of like just menial labor that just working in forms, and if you really had to build all the HTML from scratch like I did in some of those earlier examples, it's just really painful. And there's other problems too, and that is that, you know, there's just a lot of repeating yourself. We kind of want to use like object-oriented techniques and other techniques to not repeat ourselves. And it's really easy to put the HTML up for a crappy form, but why wouldn't you want a beautiful form? And so if you write the HTML and you write some CSS and you do a kind of crappy version of it, then you have to fix it or hand it to a designer, and then they have to go fix 100 pages. There are things in Django, Crispy Forms is something we'll talk about later, that just like says, hey, I'm using forms in Django. Wait a sec, I want them to be pretty now. And then you just make them pretty. And if you want to change how they're pretty, you can change how that works. And then you change them all at the same time. And so not repeating yourself, being able to like lean on utility code. Seems like, why would we do this? But in complex applications, you just fall in love with this idea that you don't have to repeat yourself. And even though I've showed you some of the things like post, redirect, refresh, CSRF, all that stuff, it's even more complex than that, especially when you start talking about pulling data from the database and putting it in an edit form and then checking to see if the data is valid. If the data is not valid, send back an error form and give them a chance to resubmit it. If they're successful, you do post redirect and then you send a message in the session. We've done all that in really simple, but if you really look at everything that you need to look at, it's pretty complex. And so we're not going to do all this in this first lecture, but this gives you a sense of the kinds of things that a create form, where you're going to go like, you know, new cat, and then you got some forms to fill out, fields to fill out about the cat, and then you hit the save. And so if we just go through this, these are the steps you need to do to insert a cat in your cat database, right? So your browser initially goes and gets a GET request, and then you fill out the empty form with a bunch of fill-in-the-blank fields. The user can always cancel out of that and get out. The user might enter some data and hit post. Now the problem is, what if you have some rules about the data, such as this is required, that has to be at least 5 characters, etc. You have to then send a form back with that data to let them fix it and resubmit it again. Or if it's good, you go ahead and store the data in the database, but then we have to put some kind of a success message, like in a session or something, and then send a redirect out, and then the browser immediately comes back and gets the redirect URL, which pulls the message out, sends the page, and sends the success. And so we've done parts of this already, right? We've done parts of this already. The big part we haven't done is kind of like this middle part here, where we're like validating the data and have this error retry loop that we put the user back in the loop and give them another chance. Now that's the create form. The edit process, where you're pulling in an existing cat and you're going to edit their fields, is even more complex. You know, you go load up a cat, but you might have an error page because they're looking for a cat that didn't exist in our database. You send out the form with the old data. They might leave. They might edit it. They might come back. They might validate the data and get an error. Then they have to fix the data. They got to go around here until, okay, we got some valid data, and then you store the data in the database, put a message in a session, send out a redirect to a success URL, and that success URL, you put out the message and say yay. So that's complex too, and we're going to figure that out. Delete is not as simple as you might seem. The problem with deleting things is that you can't delete with a GET request. So usually you have to go navigate it, like you see a little delete button. You click on it and you go to a delete page. It's going to load the data that you want to delete so you can build a confirmation page. Confirmation pages turn out to be really important because they're also our tricky way to convert a GET to a POST. But if they're asking for the wrong data, we have to send an error message. Otherwise, we send a confirmation form that says, are you sure you want to delete this? That's both nice for the user to give a confirmation, but it also then turns this into a form. And of course, they can leave with a cancel, but if they click on yes, that turns into a POST, and it has the key. So the first thing it does is it has to load the data again from the model. And then if that data is not there, they got the wrong key, then you send an error page out. And if you got the right key and the user has permission to delete the data, then you go talk to the model and you delete the thing, right? Then you put a congratulations on your deletion in a session or something. Then go with a redirect because you can't respond with a 200. You got to respond with a 302. And then the browser immediately does a get a success URL, pulls the message out of session, makes a success page with the message. Now we're going to cover this a bunch of times, so you don't have to get this the first time. But I just am telling you that forms are complex. And what's cool is Django form objects that we're going to create act like glue. They can generate the HTML, they allow for a consistent look and feel, and they allow for you to change the look and feel. When the post data comes back from the browser in a form that it created, then it puts it all in the right spot. It validates the data based on a set of rules that you say, like this has to be this kind of a thing and that kind of a thing, or a date or a character or an integer or a floating point. Whatever it is the rules are, that's all done for you in Django. And if something goes wrong, then it hands you an error form that you can send right back to the user. It really greatly, and then of course, once it's validated, it moves it into a model and then actually can even do the database store automatically. So the form is like this glue thing that sort of talks to templates, it talks to browsers, it reads data from browsers, it stuck stuff in. And so in a way, the form is like the controller, it's like the view, it just makes your views really succinct, and you're gonna love it once you understand it. So here is a simple form, and so forms live in a file called forms.py, not surprisingly. And basically, just like them, it looks a lot like the models file. And so you're going to see the one thing that forms do differently is they can have these things called validators. Models have rules about max length, etc. But there are even more complex validators, and you can even write code that you have your own functions that when the form is coming in, you're going to look at this one field and you're going to say like, oh, I wanted 2 uppercase characters followed by 3 lowercase characters. Sorry, you didn't do what I said. That's what's called a validator. And that's when that error page goes back and it says, hey, you're missing this stuff. And we'll show you how the validator stuff works. But basically, you put in little lines just like you did for the model. And you're effectively defining a user interface plus a bunch of logic behind it. Now, the one thing I'm not doing in this particular section, we'll do soon, is connecting this to a model. So you could say, wait a sec, I'd like to make a form and I really mostly want to inherit from a model. You can do that, but that's not this one. That's coming up in the whole next section, but it won't be long. So the form object, right? So here's this form we just made. It's got 3 fields in it. And this is a real simple view. It's not useful. It just kind of shows you one of the things you can do. So make a basic form. When the basic form is defined as having these 3 fields, and then you say form and then call the method as table. And so what this produces, it's just a dump. There's nothing, the UI of this looks really ugly, but basically it generates all this HTML for you, all this HTML, input tags, and we told it to do it as table. That's not necessarily the prettiest way to do it, but all that HTML is generated from the form utility. So it can send it out as a list, you can send it out as paragraphs, etc., etc., etc. And so this is just to show you kind of the dump. If you go to this URL, do a view source on it so you see this stuff in here. So that you define a form object, and one of the things you can do is make me HTML. And this is not a good example. We'll come up in a bit with a better example. The better example, of course, is to use it in a template. And so here is a template with a simple form in it. We got a form, it's a post. We got some submit stuff. We got ourselves a cancel, button that we put in, and we got a CSRF token, and we're going to use that form as table, and we're going to surround it by a table tag so that it looks a lot prettier. And so this is a far more typical way of doing it. That first one was just to dump it. And so this, when you do this and you give it, you sort of make the form in a get request, you make the form and you pass it into the context. If you remember, form.asTable, that's a very, come back. You're too far. Form.asTable came from the context, came from the passed in variable, and that is right here and right here. And so we make the form object, which has all the fields in it, and then we pass it into our view, our template, and it renders that. And so then this is what it looks like, much prettier. And if you do a view source of that, if you go to this form create and you do a view source on that, you'll see it's all that same table stuff. It's the same table stuff that we had before. It's just now wrapped in some stuff to make it look a little prettier. We put a submit button, it's got a form tag, and then you can actually hit the submit button and something actually happens. So this is by far the more typical way of using a form in a template. So I talked about the create form, the update form, and the delete form. This is kind of an example of how forms can be used. Now, I'm not actually talking in the model yet. We'll do that in a bit. So I'm just going to pretend that we have some old data. And so this normally would come from the model. This old data, title, mileage, purchase date, that would come from the model normally. But for now, we're just going to make it up. And so then you basically start a form and you pass this old data in as the constructor. That's a constructor for a basic form. From the basic form class, pass in old data and give me back the form. Give me back an object of type basic form, and I'm going to have it in the variable form, and then I'm going to pass it into context. Now you'll notice I'm using the exact same template, the one I showed you before, because that form as table understands that sometimes there's data in these fields, and it properly puts the data in. It properly escapes the data. It understands that this is a number. It understands that this is a date. It's got all that stuff all figured out, right? And so this is how it works, is you just somehow get your hands on key value pairs of the old data, you pass it into the constructor, and now you render the form, and the forms library takes care of putting in all that old data. Believe you me, you're probably glad I'm not showing you how to do, HTML encode and all these things, and when you do encode, but this is a little different because it's inside of an attribute. You don't want to know that because you just are going to use form as table, and it's got all the rules figured out. And this is hundreds of lines of code that you're not writing. So up next, we're going to talk about the validation part. So that's actually what happens when we receive data back from the browser.
Hello and welcome to another Django for Everybody walkthrough. So you are probably at this point working on your autos assignment. This is our first real create, read, update, and delete assignment. And we're going to, a lot of what this assignment is to look at the code I've given you in DJ Free Samples and pull it in. Do not clone the repository for this assignment. The DJ Free Samples is a monster. It's got all kinds of stuff in it that's way too complex. And you want to start with a nice clean application. Your previous assignment was to make a really tiny application. Now we're going to extend that application, and that's why you've already have this DJ for E projects in your wherever it is, okay? And so what this is this assignment is to evolve that using the sample code. But what I'm really going to do is I'm going to walk through the sample code because there's new concepts in this sample code. So this is more of a lecture about the sample code than exactly how to do the assignment. But importantly, you need to understand every single line, because literally
every program that we're going to write for the next N weeks is a variation on this CRUD, right? And so these views, these default views, the get or 404, all that stuff are really foundational things. And what we're going to find is the right way to write this code, like everything in Django, is really small and succinct. Okay? So let's take a look at the code. Let's go ahead and run the code. Go to autos, and you got to log in. And so the idea of this is there are two tables. There is a table of makes. So I'm going to add a make, and then I'm going to add an auto. And the cool thing about this is neon 1, mileage 1234, Sakai car, and then I have this cool drop down. And so this is there's a whole bunch of forms going on here. There's drop downs. There's a many-to-one relationship going on. Then I have this list, and I can update it and delete it. So that's where our full CRUD is. And so we can add makes, view makes, add autos, etc. And so that's all the sample. So it's very close to what it is that you have to write. It's just don't go grabbing all that stuff. So let's start by taking a look. So I'm here sitting in my DJ free samples. And if you look, you see all of my various applications under a project. And so we've got the autos, but I really want to start with the authentication code. The code that, if I go here, back to samples, let me log out, the code that allows me to log in. So if I go straight to autos, see if I've logged out. Right, so you'll notice that what it does when I go straight to autos is it routes me to login, and then with the next to go back to autos. So this view in autos, the /autos, has protected itself with login mixin. And later we'll do login. Your login won't quite look like this, but this is the one I have on samples, where you don't have to make it pretty yet. An upcoming assignment is going to make everything pretty. So now we're at autos and we're logged in. Okay, and your application has to have some more things here, but I'm more interested in showing you really the essence of the views in this autos, right? So if let's just review just briefly. Let's just review briefly about how the auto login works, right? So if I look at DJ free samples /settings.py, you need to have this auth plugged in, right? So that basically that's a bunch of code, some views, etc. that comes from Django, and that's been there all along when you did your start project. Of course, then somewhere in here we've got to have the autos, wherever autos is. Yeah, autos app config. You get to pull the autos app in. And if I take a look at DJ free samples /urls.py, then I can find autos here. And there needs to be some kind of a link that basically says at the top level, everything below autos is delegated to the URLs file in autos.py. But also then there is the accounts, right? And so if you recall, this is a bunch of views that come from Django for us. It's pre-installed for us. And the thing that we've got to do is we've got to build we've got to provide this a template with the name registration.html. So I think I've got this in home /templates registration. Yes, I do. So I've got actually two logins. I've got a really simple one is login.html, and this is the one I recommend that you start with. Later we'll use the social login. And this is very simple. It's a login page. It uses the Django Forms capability. If form.errors, that means that there was a validation error and it came back and redisplayed this page and showed you an error. And then we make a simple post form with a URL that is a reverse lookup to a view with the name of login. Then we put the CSRF token in, and then we take the form, and I'm just making this with paragraph tags. And so that's a simple login. That's not the actual one that we're showing. And then the next is a hidden value that you've got to pass in, so that when you actually successfully log in, it knows to come back to autos when it's all done. It comes back here after the login has been done. And so that registration/login, you can put this in any of your applications. but you want to name it registration/login.html. So if I take a look real quick and I go into home templates, these are all the templates. When I do an ls, you'll see that I have a home templates home and a home templates registration. You can have more than one folder here. And if I do look at what's in registration, you see that I've got this simple login and then later the more complex login that will give us the GitHub login capabilities. So we can log in using, what that means is login use social. The point is underneath this templates, you don't have to just have one subfolder. You can have more than one subfolders. And so that is the necessary configuration to make it so that when we tell our views to add the login mixin, which we'll see in just a second, when we tell our views in the login to use the login mixin, then it knows where to get the template from. So that's just part of it. And your instructions tell you how to do that. So any application that you're going to build or any project you're going to build, you have to put those in settings.py, urls.py, and then make the template. And then you have to start using login mixin, and then everything just magically starts coming together. So let's take a look at the actual autos application. We'll look at a couple of different things here. autos/URLs. And I'm going to do a I'm going to tab so I can switch back between files really fast. You probably have a better text editor than me. So I've got URLs. I'm going to take a look at the views. Nope. Autos. Views.py. Then I'm going to look at autos model.py, models.py, and then I'm going to look at autos forms.py. And so let's sort of work through these four files: URLs, views, models, forms. Probably let's do models first. So this is pretty straightforward. We're going to make a make object class. It's going to have one character field with some validators in it. We kind of played with that with forms. You can put validators in models. We've previously seen validators in form, but there's a validator that basically says we're not going to accept data coming into this database table unless there's at least 2 characters. These __str, you've been doing this for a while. That basically is if you take a model object, an actual make, and you print it, it says which of the fields, in this case there's only one field, and so that just says when we're converting a model to a string, a model object to a string, we get to decide how that looks. Okay, and then we have an automobile, and it's got a nickname with a min-length validator, max length of 200, a mileage, which is an integer field, a comments, which is a 300-character field, and then a foreign key into, this is a one-to-many or many-to-one relationship, not a many-to-many, just a foreign key into make, and then we're going to do on-delete cascade, which really means if you delete a make, then the corresponding auto entries will automatically be deleted. And so this is a pretty straightforward model, actually very, very simple. And once again, we're always defining this stir__self so that we know that we're just, if you're just showing it like in the admin interface, or if you're just printing it, or just converting the model itself to a string, the field among these fields that is supposed to be used is the nickname field, just to show to end users. So that's the models file. Let's look at the forms file next. So the forms file is interesting because we've seen forms that are just forms by themselves, but this is a special kind of form in that it's a model form, in that we normally in the other models we had all these fields, right, and we put them in and it looked a lot like a model file where we'd have a character field, a positive integer field. But what we're basically saying is, you know what, we're going to make a form here, and really all we want to do is take all the fields from the make model and make them form fields. So a form and a model are two different things. A form is something that goes between sort of the view and the template. And it'll, as you'll see, it also goes down into the models automatically, but you gotta, so this is just like make all the fields, right? Let's make a form, because form objects don't have to be associated with models, but in this case, we are going to sort of derive a form object from a model. And so instead of extending form, we're extending model form. So that's a model form must have, and this is just some data that says the model that we're going to pull all our fields from is the make model. And it only has one thing, which is a name. That's it. Okay, so this is auto-generating a form that if we changed it and added another field here, then this make form would automatically have a field. You can give it a list of fields, underscore, underscore, all, underscore, underscore, is like a signal to say, just give me all of them. Now there might be some internal things like created at or updated at or something that you don't want to use. So that's a form. Remember how forms work. Covered that before. Let's take a look at our URLs. Now, a lot of this looks pretty similar to things that we've done, right? We we basically have a main table, which is our autos table, and our lookup table, which is our makes table. And we have sort of three things. There is the main list view, which is list all the autos. There is the main the make list view, which is list all the makes. And then we can make a new one, which doesn't have a primary key, because part of the idea is the create is making a new thing, which is going to generate a primary key. And then we're going to have a update and a delete. And so we have a read, a create, update, delete. So it's not exactly CRUD, but you see all four of these things. And so we've got views, and we name these views so that we can reference them in our views themselves and in our templates. So we can make links in between them. Okay? Okay, so these are pretty straightforward and not all that different. So the fun starts to happen when we're in the views.py. So login mixin, if you remember from the Auth-Z walkthrough, you just add this to a view, and it just basically says you cannot get to this view unless you're logged in, and if you aren't logged in, it will bounce to the login.html file and then bounce back after you're done. And so login required mixin is all we need to do. If you go with the Auth-Z sample, you'll see like I did that by hand, but you don't want to do it by hand. You just call login mixin. Now, so this main view is a list view, and so let's go take a look at what this is going to look like. This is the list view. So we're going to take however many autos we have, we're going to loop through that list, we're going to retrieve all the autos from the database, then we're going to have an add the auto link, then a view the makes link with a count of how many makes there are, and add a make. So let me also then go into autos templates, autos again, yeah, I'm sorry about that, and auto list. So this is the template that makes that. And so there's a few things that we get. We get an auto list. Now the names of these are not forced upon you, but there's conventions that turn out in a moment. They're going to look really useful. Okay. So we're going to get an auto list. And if we go back into our views, we see that we say get all of the objects from the auto table, all the auto class objects, retrieve them all, pass them in to the context as auto_list. Now we also want to be able to show that little count, this number 2. So we're going to ask, go ahead to the make objects all, but don't give me a list of them, count them and give me a number. So make count is stuck in there, and you'll see if make count is greater than 0, we can show the add an auto button. And it also somewhere, shows the make count, view all the makes, add a make, and the make count comes out here. So that's another thing we put in. The auto list we're going to go through, and that iteration variable of auto is going to go through each of the separate things, and nickname, make, etc. That's right straight out of the models.py file. There's the 4 things that every auto has, and we're just printing all this stuff out. You also get the primary key, and so we're going to make a update URL, and that URL is to autos auto update. So if we look in urls.py, we see this auto update looks up this, gives us a path to the view, but that particular path needs one parameter, which is a primary key, and so that means that this URL template tag Autos has to have the auto ID. But because we're looping through the models, you got one, right? So, and you do an auto create, that's pretty straightforward. But one of the rules is you have to have at least one make before you can do an auto, because if you recall, add an auto has to have this drop-down list populatable, and that's being pulled from the make table, okay? And so that's basically the way around this. That's the main view. Now, just like I showed you before, it turns out that there are here we go. Auto create update. Yeah, that's the autos view. So, and then if we do the make view, we're doing the same kind of thing. If we go and look at the make list, we're doing the same basic kind of thing. View all the makes. This is the, and now we got update and delete. We are, this way you don't need a count. We just want to grab all of the objects. We want to put it in a context under make list, and then we do make list under HTML. And this is even simpler. It's just going through the make list. It comes in through the context. If there's none, we don't print this out, and then we put out the name of it, and then we have an update and a delete button that goes to the update and delete. And of course, those, if you look in urls.py, those also, the update and delete, have primary key requirements. And so you have a primary key that you got to pass in here to make that URL the proper kind of URL. And then just some links to go back to the various things so that we can, you know, get back to autos, view makes, add a new make, you know, cancel, all that stuff. Okay? So that is the views.py for listing the autos and the makes. Okay? Now, we want to make the make create view. Okay? So if we take a look at the make create view, that is add a make. That's going to create this form. Can make this bigger here. Create this form where we're going to put in a thing called Chevy VY. So we need a way to make this form, right? And so we're going to make it a login required. We're not going to let folks do this. We're going to have some variables that are class-wide, like what template we want to use. And success URL is after we have done this right. Now, if you just submit it and it complains, it doesn't do it. But once you've done it right, where do you want to go afterwards? So Chevy. Where do you want to go afterwards? This is a controller function. Boom. I want to go back to the auto list. And so the success URL is go to autos:all, which in urls.py is this main view. That's the name of the main view. Okay? And so if we go here, which template to use and which success URL. If we do a get request, we're going to build a form for the make. That comes from make form, but really it comes from the make model, which is just one string field. It's simple as that, right? We're reusing this. We're just saying, let's make a form that pulls from here. We have to pass a form in because models can't be used to create this kind of a screen. That screen comes from a form, okay? And so if we take a look at the template, oops. If we look at the make create template, make form. So that is, yeah, that's the template we're going to use to make form. We're going to need form as table, right? So that's from how we did forms. Put the CSRF token, you make a table, that could be as paragraphs or as tables, but whatever, you need this form object. So you need to pass the form object in. And so here we are. We're going to make a form, and then we're going to pass the form object in, and then we're going to render it at self.template, autos.makeform, HTML. And then we're going to return that for the get. And then when we hit the button, the submit button,
add a make, we hit the submit button, it's going to do, it's coming into the post because we made a form post, comes in, we're going to take the, oop, don't do that. Oh, that's terrible. I hate it when VI does that. But here we go, we're back. Yeah. So, post comes in, request.post has all the key value pairs, which are these key value pairs as defined by the form. So we say, let's make a make form with the initial data coming in from request post. And given that the form generated it, it knows what the names of these fields are, and this is something that hides behind how forms work. But it also checks to see if the form data is valid. And that means, were all these validator rules followed? If the validator rules are not followed, if not form is valid, we're just going to send it back. And so so this code here, this if form is not valid code, if I put in a single letter, A, and hit submit, it's going to come back and re-render the form, and all that error stuff, all that stuff is all handled by this form code. This Django form code figures out what is wrong. Right, let me move this over just a little bit so I can get back to it faster. There we go. It figures out what's wrong with it, makes an error message. The error message came from models.py right here. Oh no, right here. And then went through forms.py because it is a form ultimately that we inherited from model form. Get it? And so that's cool. So that's the error condition. And otherwise we do form.save. Now the thing here is that's really super cool is because this form is a model form. It knows this, and the field names are the same as the field names in the model, and so it actually does a save on the model itself. So in a way, the form contains the model data that came from the post request, and then it saves it. Okay? That saves the form. It puts it in, and then we just redirect back to the request URL. So this is pretty succinct, right? We pull in the post data. We check to see if it's bad. If it's bad, we send it back, send the form back to the exact same template we did, and then we save it if it's good, and then we pop to the success URL. That is a beautiful thing. But just like in Django all the time, this is a far wordier thing to do, even though this is super succinct. And if you did this in almost any other language, you'd be like, 75 lines of code. And here we have like 15 lines of code. But it turns out in Django, there's almost always a more succinct way to do it. We have a generic create view. You can take a look at the documentation for this generic create view. Django views generic edit. Let's just go and Google this stuff. I always just put a dot here, and this usually gets me right to, because that's the actual package and the class inside the package. Oh no, sorry. It thought that was a domain name, so the search didn't work. But now I'll just say, Django something. Look like, so at least it's going to do the search for me. Generic editing views jump to the create view. So you can read through all this stuff, right? Generic create view. Actually, let's make a, do I have a reference to this? So there you go. Take a look at that. Now, this, just like some of the other views that we've inherited, have a ton of functionality in them. So if I want to do an auto create, this is all it takes. Now, auto create and make create, for all intents and purposes, do the exact same thing. So what happens in auto create, because we're extending create view, we have 3 bits of metadata. We tell it which model we want to use, which fields from that model we want, and where the success